Oh, yes. Well, hello there, everybody. Welcome to SkyTour live stream on this wonderful January 20th, 2023. This is a nice night. We had some clouds out there before, but the clouds have abated, and that's our sky right now with the AllSky camera. I'll do one more acquisition just to make sure, and we'll come right back to that. But it looks like a beautiful night, so we're just taking some photos. This is an object that one of our wonderful SkyTour members has requested, and we're going to do a deeper dive into this at some point, and it may not be tonight, but we may just wait a little while. Anyway, I wanted to just welcome my buddy and old astronomer pal, Daryl. Hey, Daryl, how you doing?
Wow, I'm good. You?
I'm good, man.
Hello, everybody.
Yeah.
I'm cold, actually. I feel like I'm having a relapse or something.
A relapse of winter.
Relapse of last Sunday. It feels chilly.
Yeah.
What can I say? But yeah, as you said, it's winter and it's snowing outside, and I got my heavy winter socks on. I may go put a heavier shirt on.
Yeah.
But carry on.
No, I mean, go do that now if you want to. I can certainly fill the dead air for sure, as you know.
Well, that's okay.
I want to welcome Michael Hedrick. I want to welcome Michael Galia, who has joined us here. The first one in the room tonight was Maya Leon. Hello, Maya. How are you? It's so cool to see you. Fantasies with us tonight as well. And SkyTour. Who's he? ERRT Radio. Ronald is here with us. Hi, Ronald. Welcome again, as always. And Marianne Robb, I think I've heard that name. Marianne's with us as well, just starting out. And we have, let's see who else is with us. I might as well just go through while we're here. And I think Bullwinkle's with us. There we go. Yeah, Bullwinkle, Sam S. How you doing? Sam, I think, as you noticed, I sent you a reply to your email requesting the Cat's Eye Nebula. And as Daryl and I had checked it out, after we figured out that it's really going to be up in the late evening, early, more into the morning. And we're not quite ready to start looking at that yet. But when we are, we'll make sure we look at that for you. All right? But thank you for that request. Cosmic Ray is with us. How you there, Ray? And Renee Cruz and Bonnie Anahata 77. How are you, Bonnie? Nice to see you. And we are going to have some fun tonight, checking things out. Izabela's with us. Donald Kunzer's with us. This is one of Izabela's objects that she'd like to look at in depth. Izabela has won a evening with us to do a nice tour of her own, and I'll explain how that all happened shortly. And Ronald, also ERRT Radio, will be getting one as well. All right. And Ronald has been doing some stuff behind the scenes for us, and so that's why he gets it, and same for Izabela. She's been doing quite a lot behind the scenes for us, as you all know. So the least we could do is give her an opportunity to just take the telescope and run with it. Now, obviously, I have to run for her with the telescope, but she's going to be in charge, and we're going to find out what she finds to be interesting in the night sky. I don't think that's tonight, but when she gets her list fully set and everything, then we'll do that for her. And then she'll join us on the air as well. Hello, Judy M. Nice to see you. So, that all said, let us keep going here. This object, then, what we're looking at, this is called Hind's Variable Nebula. And it's Hind's Variable Nebula because, well, as you might have guessed, it varies. All right, and Hind's Variable Nebula is a dark nebula that has a small emission nebula in its core that varies in brightness. And this is something that's very interesting. We love these kinds of things. And it's an emission nebula, and it's mostly a dark nebula. So it's emission and dark nebula, right? So just so you see, there it is. Okay, we'll put that out there for you so you can see what it is. And you can see it right here. It's pretty obvious. And we are doing 65-second shots of this. which is why it was already running when we got in. Okay, I wanted you to see that we were doing this along the way. All right, so it's not ready for prime time yet, but we're working on it, and we're gonna try and give it a few more. We have 18 stacked images of it right now. All right, and so this will be it's something that we will explore more than just once. Okay, this will be the third time SkyTour LiveStream has looked at this object. We have not looked at this but only 2 other times. I couldn't believe it. I went through the database that Robin Curtis has put together for our SkyTour sessions, and there's only 3. So here you go. This is showing you a little bit more about what's there. We can also do a pop on this, and so you can get a little bit more detail, all this stuff that's out there. Let me actually remove that guy. Come here, you. We don't need it up there right now. But you can see all this dust out here that is populating this area of space, and then you have these little darker areas here. And so we see a lot of that in the universe. And this will reduce some of the noise by not popping so much for that, because then the noise comes out with it. All right, so we can play with these down here, those guys down there. This is our dark level. So if we just take the dark level and move it to the left and the right, okay, it takes us off the curve of the data here, and so we see a lot more brighter sky. If we start riding up that curve and we go up that curve, you'll see that more of the data is clipped, and it actually helps us see the contrast of what's going on inside. We also have a scheduled maintenance visit to the observatory Sunday morning, and Marianne and Tara are going to go out, and they're going to remove the camera, and they're going to go out and they're going to fix the camera's streaks that we see here. They're going to clean the sensor. They're going to replace desiccant tablets inside the camera, and do the maintenance that I would do if I was going out there. So they've been trained to do that. There's written instructions for them, so I have a feeling they're going to do a great job. So the next time we use the camera after Sunday, I think we're going to see some really, really nice imagery, even more so.
Oh boy.
I know.
Mark, Michael Hedrick asks, is T-Comp on?
It is now, and when I saw his note, I immediately said, oh, he's right, and I clicked it on. So thank you, Michael.
Okay.
Yep. And it was because of his note that I turned it on. See, I had done the autofocus. I'll just zoom in here. You can see some of the noise, but you'll notice the focus looks good right now. All right, and the noise, that modeling you see, that's noise that gets averaged out, and as we keep going here, you're going to see that more of it goes away. This is just beautiful. Just beautiful. Stunning. Beautiful. Let's do this. Soften everything for a moment, so you can see this very delicate band right there. Now, watch that delicate band as I move this in. Okay. See that? Look at this beautiful little band right here. This is gorgeous. Yeah. So there's a star in here that is exciting this to glow. It's hot enough to ionize some of the hydrogen mixed with this dust. And it's really, really looking very, very nice. And it's an example of what happens when a star winks on inside of a dark nebula like this. So, and again, this is Hind's Variable Nebula. It's an emission nebula. Tiny little emission right there, and a dark nebula, mostly. And
where is it in the sky?
It's actually just below, I believe, the Pleiades. Let me go check again. Let's go look. Yeah, there's the Pleiades right there, and this is where we are. And just a little bit to the east of the Pleiades. This way is east, that way is west.
Just above the Hyades.
You got it, because the Hyades are right down here. Yeah. So if we zoom in, we can actually see that. There you go. It's actually kind of in the Hyades.
Yeah, I guess I was thinking of Hubble's Variable Nebula. That's the one
Oh yes.
down under the cone, I believe, in
Yeah, it is.
Monoceros.
It's a little bit southwest of the Cone Nebula.
Okay.
Yeah. And so this nebula here, if you look where the telescope is pointing over my head, you can see that this is pointing pretty much almost straight up. So this is going to give us the best view of this object that we could get. All right, just like this. So let me see if I can color correct a little better. Yeah. Yeah, so we have a... This is really pretty. So this is a nice looking object, I have to say.
I have to ask, so what makes it variable?
Well, that's a good question. I'd have to look up any papers that might exist on this. But I think that anytime there's a variable nebula like this, there's some kind of dark dust in some kind of orbit around an inner star inside the nebula that's actually projecting a shadow, which makes these variable. Or you have a star that is young and pulsating, or old and pulsating, and it could be causing variations in brightness, because most stars are variable stars, right? So our sun has a cycle of its own, the sunspot cycle, that changes our solar output in a perceptible way, but not very much. And so every 11 years we have a cycle of sunspots and no sunspots, and we do have a difference in output. So our sun is a little more stable than most, but we do have differences in brightness that occur in periodic manner, either via the star itself or the dark dust moving around the star, as in the case of Hubble's Variable Nebula. Hubble's Variable Nebula has a star that has a dark swath of dust that's orbiting it, and every now and then it'll cast a shadow on Hubble's Variable Nebula and cause the nebula to change in brightness. We have seen that brightness change, as you've pointed out as well. Yep.
Okay. Oh, well, this is T Tauri.
Yeah. So this is the young star.
And it's a Herbig Haro object.
Yeah. Herbig Haros are well known for being variable in their brightness and the way they emit different amounts of energy over time, and the Herbig Haros are usually young stars that have just winked into existence or are on the verge of winking into existence. We see a lot of those, and these are actually pretty common in the universe. We find a lot of them in dark nebulae as well, because that's where they would form initially.
Can we zoom in a little bit?
Yeah, we can. I was just thinking that. Let me first take down a little bit of this, just a bit. All right, there we go. Let's zoom in on that star. Well, there you go. Look at that. There's a lot of detail in there. Yeah, that is really cool. Not bad. I'm going to see if I can increase our contrast. First things first, let's see if we can sharpen this up a bit. There we go. Now we get a little more delineation in some of this detail. And come back here. Now let's just take this and go like this and pull this in just a little more, and then pull this in a little more. This will tend to brighten the data, but it'll bring in some noise too. But let's see how far we can go before that happens. We can go way in, and it's gonna make it look pretty messy, but you can see there's a lot of data there. If we back out, you can see that there's a lot of data in there. Yeah.
T Tauri is actually a triple star, and its distance is more like that of the Pleiades.
400 light years.
Yeah, 420 light years, I think. So it's behind the Hyades.
Mm-hmm. Let's do this here. All right. And now I'll pull this in. All right. I just, for those of you that are new to SkyTour LiveStream, there's a few of you actually out here. This segment here, this is our telescope control section right here. Okay, this is our telescope control section. All right, and let me do it this way. So telescope control here. This is a telescope control panel, which right now is blank. This is the telescope in the building with the roof off. This down here, what can I say? Look, you leave the door open, anybody can come in. This, of course, is our main screen. This is our telescope camera system and focus control center. And this is our stack center when we're running a stack. So we have all these separate sections surrounding our absolutely beautiful screen. And the thing is about this, what we'll do most of the time when we are capturing a large scale object like this is I will do this. I will take and move our everything over, and I'll take the stacking window and move it down and give us the whole screen. And once I know you know what the thing is, I will remove the name there so we don't need it. And so then we'll just have the object in the view and just enjoy the object while we're looking at it grow. And we're stacking. So what that means is we're taking an image, then taking another image, aligning it with the first, stacking it on top, and just making an image sandwich. And the more you do that, the more the dim, small objects that are data, like the dark nebulae, right, pop to the top and become brighter peaks in the data. And the more the noise, all the stuff that makes the image hard to see, get averaged out. So they go away. So this is what we're doing right now, is we're actually stacking, which is why we're sitting here so long. And right down the bottom here, you can see that we have stacked 29 of these images. You can't see that right now because we're here. But if I bring back the telescope here, all right, you look down the bottom right now, right there. Make sure you're on 1080p on your stream. You can read down here. It says 30 stacked images, right? And that's pretty good. And so what I'll do is I'm going to stop it here. I'm going to pause this and save it. Now, when I save it, we're going to save it in the astronomical file format called FITS, F-I-T-S. And then we're going to save it exactly as you see it here. All right. Now, what good is that? Well, what good it is if you go here, SkyTourLive.com, or you look over there in the chat, okay, you'll see that Izabela has put the website up there as well, SkyTourLive.com or SkyTourLive.org. We are a 501c3 organization. And as such, we're going to be doing a lot of this work for public consumption. Right? And these images we take are going up to our SkyTourLive.com server, which are available to you for free. All right, you can download them to your heart's content. If you want to join our Patreon, SkyTourLive.com, go to the upper right and you'll see Patreon. If you join our Patreon, you have $5, $10, $100, and $200 per month Patreons. But people like to do the $5 and $10 ones. And if you want to do that, you get something for that, and we're going to actually have some surprise gifts for those that do the Patreon with us as well, moving forward. We're working on that right now. But right now, you also get, for the Patreon, you look at the Patreon rewards, and you're going to see that you get things like access to highly processed finished images that you could put up on a wall or frame. And these highly processed finished images are big observatory quality images that we've created here with this system. And it's amazing to see what you can do and see what we can do with this system. So you get a chance to see that, and you get a chance to download and keep, to do with what you will, these large images. You just can't resell them, and those, obviously. But you can get them printed, you can get them on canvas, you can get them put on metal, you can get them on stretched canvas, or you can get them on paper print, framed under glass, all that stuff. And so these are really interesting. These are really interesting photographs when they're highly processed, and those become available to you when you subscribe to the upper levels in the Patreon. But anyway, that's pretty cool. I'm glad that, like I said, I do this for free. We don't have, we do have bills to pay, of course. We're naturally our internet. It costs us, a lot of money a month to pay for the internet and to bring this to you. So that's what we're doing. Anyway, this is.
May I ask a question?
Yeah.
Not to sound like a doubting Thomas, devil's advocate perhaps. Does the idea of a 501c3 conflict with Patreon?
Not at all. In fact, Patreons are made for 501c3s too.
Okay.
Yep. In fact, that's a better way to do funding for a 501c3 is a Patreon. Because the Patreon subscriptions go into the 501c3 account and not to anyone's pockets where it can get lost in the ether. You're going to a organization where we take seriously the outreach in astronomy and science, And so the money that goes there goes strictly for furthering astronomy education, and that's it.
Very good.
Yeah. I'm on a STEM board here in Connecticut where I live, and STEM stands for Science, Technology, Engineering, and Math. And, we're following STEM requirements with the 501c3 for the most part. We're actually trying to make sure that people who come here understand that we're doing all these things in accordance with the STEM approach, because I was a fortunate recipient of an education via somebody using a school curriculum using the STEM approach, and it made a huge difference for me. So I'm sure it'll make a huge difference for other people too. All right, so we've done this now. We did 30 images, saved a variety of ways, and we will get rid of this stack, go back to our 1 second shot, and go into what I call night vision mode.
Well, question, did you name it?
Well, yes, it's called the Pleiades. It's called the wrong thing. Yeah, so it's going to show up in the Pleiades folder. I'll fix that later, don't worry. It's going to say Hind's Variable Nebula. Thank you, Daryl. Look, a satellite. A lonely little satellite. Look at it go. Yeah. It's a 1 second exposure. That's why it looks like it. That's a dash. It's not long. It just streaks out after 1 second. It's actually a little dot. If we were to reduce the size or the timing, you'd see it get a little shorter. There it is. Now it's only 500 milliseconds long, half a second. Okay? So there you go. Yeah, I forgot to name it. My apologies. I'll take care of that. Yeah. Thank you, Izabela, for putting it up. Ronald, he already took off. Okay, he's going to do his show. Fine. That's great. That's at Mixler.com, ERRT Radio. Check it out. All right, so let's go see what else we have up for bids here. Let me first go and get us another image of the night sky with our AllSky cam. That's very important to make sure. Okay, that looks like it's going to be fine, but I'm going to do it anyway. All right, this is our winter Milky Way here. If you look, you can see Orion right here. All right, there it is. And so we've got right here, you can see the square of Orion. All right, you see that? We've got Betelgeuse, we've got Bellatrix, we got Alnitak, Alnilam, and Mintaka, the 3 belt stars. There's the Orion Nebula complex in there. Then we have Safe down here, and we have Rigel over here. All right?
You can see the entire winter circle too.
That is correct. That is correct. We have Sirius over here. We have Procyon over here. We have the Gemini twins up here.
Pollux and Castor.
Yeah, and we have Auriga up here with You can see
Capella.
this Capella and the kids right here. And we have Mars. We have Aldebaran and the Hyades right here. And we have the Pleiades right here.
And Rigel complete the circle.
And Rigel right there, yep. Yep.
And if you draw a line from Rigel to Betelgeuse, that makes the heavenly G.
So if we go from Rigel to Betelgeuse, it's off a little bit, yeah.
It makes the big capital letter G.
Okay, let me get rid of that and do it again. So from
start at Aldebaran.
Okay, we're gonna go Rigel to Betelgeuse, Aldebaran to Capella,
Castor, Pollux.
So from Capella to Castor and Pollux?
Yes.
Okay, like that. And like that.
And from Pollux to Procyon.
Pollux to Procyon. Right here.
And Procyon to Sirius.
Procyon to Sirius.
And Sirius to Rigel.
And as you can see, the letter is forming itself. And then Sirius to Rigel. And there's your kind of a G shape. Interesting.
The big G.
Yeah, it's the big G, man. And we have the big T right here. That's turd. The bird turd. Very nice.
And that's Jupiter over in the lower right.
Yeah, this here is Jupiter
over
right
in
here.
The southwestern sky.
Yeah.
Michael Hedrick has a question of you.
That's our little Jupiter down there. Michael Hedrick, he asks, what are some of your favorite books and videos recommended about astronomy and the universe? Oh my gosh, where do I begin? Okay, I have to tell you, I've read so many texts, so many books that they all run together in my head. I do have one that I like. It's called The Populated Universe. I know. That's a little self promotion there, shamelessly. Let me erase this. There's some good books by Carl Sagan in astronomy. I also like some of the beginner astronomy books and I'm trying to remember some of the names. I've got a whole library of them, and when you're asked a particular title, it's like my head. I have to get into that, but I'll get to that. I'll get an answer for you. But I think Stephen Hawking's book, A Brief History of Time, is phenomenal. It gives you a perspective of the universe that I think is really interesting. And I think you would really like that as well. Let's see here. Let me get out of this. All right, we got a good night there. All right, so Izabela didn't waste any time. The Populated Universe, yeah. I wrote that because I felt that the universe is a big place, and we're doing studies of exoplanets now. So the book is a study in the very strong possibility that life in the universe is the norm, not the exception. I know not everybody agrees with me on that, but I base it on the existence of, and in fact, abundance of carbon atoms in the universe. And I won't go too much more into it than that, because then that'll prevent me from looking for other things to show you. Now, at this point, I think we are a little early for looking in Orion tonight, but there is something up north that I want to check out, and I'm going to go there now, and it's up here. All right. Let me do it this way.
My astronomy reference library is so far out of date. It's out of date.
Well, that's okay.
I have box after box full of books and a bookshelf full of books, and
yeah,
there are some of these things going back over 30 years.
Wow.
We're going to the Tadpoles and the Flaming Star.
Yeah, at least I'm trying to find. It's not the Tadpole Cluster. I wonder if it's got the.
You had the Flaming Star. It's right next to the Flaming Star.
Yeah, I can see it, but I'm just trying to find out what's the NGC number on it, because it's not the Tadpole Galaxy. And it's not the Tadpole Cluster. Let's try Tadpole Nebula. No. Are you looking up the NGC? Because I want to find it by that. It might be a lens object too. Might be in the letter Y cluster too. All right.
Didn't like that.
All right, that's okay. It's in the letter Y cluster, so we're just gonna go there. It's this guy right here. See the tadpoles. Well, duh. Okay, sorry. We're gonna go to the tadpoles. There we go. If you watch the telescope's gonna go racing in another direction right now. Hey there, how you doing, Rob? Rob Max is with us. Yeah, Rob, we're gonna be looking at the new comet here pretty soon. By the end of the month, in just 10 days, it'll be just above Polaris or so, and we'll be able to check it out. So the telescope's will be pointing right out the back of the building as you're seeing it right there. It's going to be pointing out that way, and it'll be, aiming right out this way, so we'll be able to see it, and it's going to be really pretty. Michael Hedrick, yes, the Tadpoles of Auriga, and there they are. So this is another one that is really special, and I'm going to just move us a little bit eastward to center it up a little better.
Hi, Tara. Tara's here.
Hey, Tara Diulis, how are you? It's so nice to see you. Tara and Marianne and I spent about 4 hours today. We had our first annual SkyTour LiveStream business meeting, and we came up with all kinds of wonderful things to help further our experience for you all. We're very excited about what's coming this year. We really are. Okay, so this is good. Alrighty, we're gonna let ourselves stabilize. You'll see it says searching over here. It's looking for a guide star, and once it starts guiding, we see those numbers, calibrations, and then it starts guiding. I give it a couple seconds to stabilize, and next thing you know, it will be ready to go.
Hopefully we don't have to wait 10 days to see the comet. It's actually above the horizon right now, but it's very low in the northeast.
Yeah, it's below our wall. It's down there, and we can't look down that low.
It's actually circumpolar now, and we would have to wait at least till midnight or 1 in the morning for it to clear the wall right now, I think.
Yeah.
But that is going to get earlier night by night here.
Yeah. Okay, 45 seconds. And you can see down here, this is the progress bar down there on the right. Right, over here. And that's moving up to 45 seconds. We're going to get out of night vision mode, go into our stack, clear the last stack. All right. And so that's already saved to the database. And now, once the next object reads off of the chip, it'll replace this. And you'll see it starting right about 9 seconds from now. And you'll see the tadpoles show up, and then we'll point out the tadpoles and show you and tell you all about them. And here they come.
We should be able to see the comet by 11 p.m. on January 24th.
Okay. Oh, there we go. We have a faint satellite that went through right here. So I don't know if you can see that. All right, so this is the tadpoles, and when you say tadpoles, what does it mean? Well, there's a feature inside this nebula that we're looking at now. First of all, this nebula is an emission nebula. You can see this hydrogen gas here that's ionized and glowing, the characteristic red color of hydrogen alpha, as we call it. And there's a young cluster in here that is responsible for illuminating a lot of the tadpole structure, right? And you can see there's some really interesting structure already developing here, and we've only stacked 2, right? But you also see there's a few more structures out here. And this is one of the tadpoles right here. And here's the other one right there. And you'll see those in more detail in just a moment. Okay. So we have this guy right there. And we have this guy right here. Those are the 2 tadpoles. So keep an eye on those. It is pretty already, Tara. Tara. We should have a frog nebula nearby. That's true. That's true.
There is a spider and a fly nebula nearby.
That's right. This way, there's a spider and a fly, yeah. And we imaged that the other day. The spider looks so much better in our most recent views. I thought of it as sort of a boring little nebula, and boy, was I surprised. Boy, I was surprised. It really looks beautiful. So, sorry. It's actually it's over this way. We'd have to move everything over, and we'd see more detail up in there. It's sort of up in there. We'd have to go look at it. All right. So let's zoom out a little bit here. Okay, and I'm gonna just bring up our stack again, and I'm gonna dock everything here. Just a sec. There we go. Okay, now let's see if we can bring more detail out. See, this yellow curve is the intersection on the data here. So the more we intersect, the more we see. Right, now look at that. You can see there's a lot going on in here. And look at the tadpoles now. Now you can see they stretch for quite a distance. A very interesting set of features in this. And this is, as I said, this is the tadpoles. And it's just beautiful. How nice. Okay, so... yeah. And this is also an emission nebula, but it's also a dark nebula, so it's both. So it is an emission and dark nebula, the tadpoles. And again, we call it the tadpoles just because of this feature that we see right here. These are the tadpoles in here. They're little hydrogen emission nebulae segments that have differentiated from the rest of the nebula. Technically, it's not the only place it's happened. I mean, if we actually go over to the right side some more, okay, we can see that that's also happened. All right, like in here and down here, and we can see that there's some dark nebulae spires sticking up as well.
If the cluster is the center of the nebula,
yeah,
I assume the tadpoles would be like the pillars that we talked about the other night in other nebulae.
Yeah, this might be an area that has been eroded by these hot stars.
You see they're pointing away from the cluster.
Yeah. Just like with the rosette, just like with the eagle, and just like with the cave and many other nebulae that we look at, we see those pillars. NGC 7822, which is another one that has these beautiful pillars sticking up, and they're pointing at the cluster. That's not coincidence. They're pointing at the cluster because the cluster's hot ultraviolet radiation from those young stars is eroding and pushing the dust and gas away from them, and they tend to carve out a cavity in the middle of these regions. But those cavities that they carve out are only able to be done if it's all very, very light, non-dense material. But most of the time you'll find knots of density that can stick around and withstand the assault by this hot ultraviolet radiation and these powerful stellar winds of protons and electrons zipping at them. So right here at this end of this right here, perhaps we're looking at a location where that's actually happened already, and the stars, for instance, in here, okay, these stars here are this knot of material here is dense enough to withstand the force of the stellar winds, and so what's behind it gets protected, right? And so that is what's happening here possibly, and the stellar wind keeps pushing stuff back, but the stuff that's densest at the front end, necessarily just by the way the physics works, will still be there.
Interesting when you consider the dark nebula there on the lower right.
Yep.
I mean, when we see a dark nebula, you can generally say that means it's closer to us than what's behind it, at least. But it appears that big nebula, a dark nebula, appears to be behind at least some of the stars in the direction of that cluster. If they might, if those stars even actually belong to the cluster.
Yeah, it might be that what we're looking at there is, again, a three-dimensional line of sight effect.
Yeah.
Don't know. I mean, but you know what? If we can identify all these stars and probably get distances to them. We won't do that tonight. And Tara says it's sort of reminiscent of the rosette a bit. And I guess it sort of is, but the rosette in the same way, young hot cluster carving out a cavity around it, But again, this is in 3D, so it's hard to see that. It's not going to look like a sphere because it might be denser in the interstellar medium here than it is over here. So maybe the material here was able to get pushed farther, faster, sooner than the material here, running up against some heavy-duty interference with the other material that's already out here. Hello, Alice. How are you?
Would it be fair to say that the dark nebula is closer to us than the actual star cluster or the tadpoles themselves?
I'd have to look and see, because my guess is that they're mingled among it. I think that this dark nebula is mingled inside of all this, and it just so happens that there is a higher density of dark nebula in here than there is gas, hydrogen gas, so we may not be able to see the hydrogen glow as easily because the dust is overwhelming it. That's a guess I have right now, but that could be true. Yep. Yep. But this is really a beautiful location. And the next telescope that we're getting, we've already got nearly all the money for that next scope. And we're going to be doing narrowband imagery with that next scope. Now, give you an idea what that is. When you look at a nebula like this, you can pick apart the nebula by the kind of light it produces. A nebula like this certainly gives off something called hydrogen alpha. That particular wavelength is due to the one particular transition of the electron back into the hydrogen atom when it gets ionized by these hot stars. And that color is red. Next, there is another line of doubly ionized oxygen called O3. That's O Roman numeral 3, O-I-I-I kind of thing. And that color that you see is going to be this characteristic greenish blue. All right. And you don't see a whole lot of it here, but we are filtering for it right now. So it's a matter of getting our color balance right in order to show that well. And depending on the density of the oxygen 3 and the density of the hydrogen alpha, one or the other may be dominant in the nebula. Okay. So what we see here is that. Now, the narrowband filter that's next is the sulfur 2. Sulfur 2 is another emission that comes from these nebulae, and those three, hydrogen alpha, oxygen 3, oxygen, doubly ionized oxygen, okay, and sulfur 2, those three make up the narrowband filters. You put those together, you take a picture in hydrogen alpha, doubly ionized, O3, and you take a picture in sulfur 2. And then you put those together, and you get a much more detailed image and picture of how this nebula looks. When we start doing that, we're going to do a narrowband imagery of the tadpoles. And it's going to be closer. It's going to be a bigger, higher focal length, so we're going to have a more magnification. Our native magnification, in fact, when we get that system in place, is probably going to be more like, like this. So that's going to be kind of nice, maybe a little more. All right.
I wonder why they picked sulfur. I mean, the what you just described as the SHO palette, the Hubble palette.
Yes.
They paint sulfur as red, hydrogen as blue, and oxygen as green.
Yeah.
Why sulfur? I mean, sulfur is not nearly as common as oxygen or hydrogen.
Well, sulfur has a very specific spectral signature, and it's present in these nebulae, and it literally paints the edges very well. I mean, it helps delineate a nebula quite well. If you look up sulfur 2, you'll see there's many descriptions out there of sulfur 2 and how it came to be in the narrowband palette. So I think that probably makes it's probably better to do it that way than have me go through it. But again, when we have the narrowband filters, you'll see what I'm talking about. Because when you take an image with just sulfur 2, right, you're going to see how it's going to look. When we get to the Spaghetti Nebula, just wait till we do the Spaghetti Nebula with sulfur 2. Okay? Now, people listening to this go, Spaghetti Nebula? What's this guy on drugs? No. Okay, you have to... There's colloquial names for these things, and that's one of them. So, look at all the detail in here, though, huh?
Like tadpoles.
Yeah, exactly. So as we back out of here, you can see how much detail is in here now. And I'm going to kick it up with this histogram over here. This will show us more about what's hiding in the background. All right. And so I'm going to do that. Let's do it this way. Okay. So now you can see there's so much more hiding back here and up here that we're going to be able to pull out once we get moving. All right. But for now, we're just going to come back to this, and we can just bring this up a little bit, right up the curve, and do what's called a push. And then we can get this near the peak of the black, and that'll darken it up just nice. Wow. That's pretty. That is so cool. Tara says, spaghetti with sulfur meatballs. Very good, Tara. Yeah, that is so cool. Yeah, and Donald Kunzer finally decided to join us after watching Mystery Science Theater 3000. Wow. I've always loved that show. And you asked me before, Daryl, Joel was my favorite.
Yeah. I like Joel and Mike. Joel was a little edgier, I thought.
Mm-hmm.
The older shows in general were a little edgier.
Yeah.
Mike was good too, though.
Mm-hmm. All right. Okay, so we've stacked 21 of these. I think that's good for this. So I'm going to name this one now because it's probably a good idea. I don't ever forget the name. How did that happen? I've been doing so well with this. Okay. Oh, and by the way, since you guys all know what this is, I will take that out of there. Come here. Yeah. You don't need a nameplate. Okay. So, we are now... I'll let this one exposure come in. Give us an even 22. And there we go. And then I'll pause. Save it. And then save it exactly as seen. All right, so now the research fits file is there, and now the ping file is there, so you can get this exact picture right there. And all you have to do is go out there and get it.
Can you bump the image just bump the image to the left just a little bit?
I mean, like move it to the left.
Yeah.
This is the right edge.
Oh, okay. Never mind.
What do you want to see?
Oh, well, I was just curious. It's like you have 3 pairs of stars there up at the top right.
1, 2, and 3.
Yeah.
Yeah.
And it's almost, another 3D thing. It's like they're coming out toward us as we move from the upper to the lower set.
Oh yeah. Now, just to think about, when you look at this, you say all these stars. Now, if we just zoom in on a nondescript area that'll never be seen again, probably by human eyes up close for maybe 1,000 years. If we zoom in here and we look at that star right there, okay? That one star. That star could have planets around it that has life around it, has life there, okay? So you can see by looking at an image like this that our task to find life in the universe is actually pretty daunting, But I think that it's something that we're doing because we know that we have to leave this planet someday, and when we do, we are going to need to go somewhere. So we're going to have to find a planet that we can live on, that we can survive on. And it won't be in one of these nebulae, because these are really hot, rarefied areas. So planets in here may exist, but they're going to be extremely hot, most likely sterile of life. It's the ones that are outside the nebula and the ones that exist after the nebula has gone away, after these stars blow all that dust and gas away, and then these stars themselves migrate away in hundreds of millions of years, that they will then foster life. Like our sun. Our sun was born in probably in a cluster like this, and it was born with a bunch of other suns. And I say that because they would have the exact same composition as our sun. Very, very close, if not identical. And we've already found one solar sibling. And still looking for more. It's in the southern hemisphere. It's a nondescript star, like one of these I just went to. But it has the exact composition of our sun, which means that it was born with us. And just like all the stars you see in this cluster in the middle here, these stars will eventually, through gravitational interactions, whip themselves away from each other and move off on their own, like leaving the nest, like getting a car and driving away from the house for the last time. And when they do that, they're going to be separate from their original birthplace, as we were. And then maybe they can foster life at some point, as we did. So you see, there is a great evolution path in the universe, and it's just amazing to contemplate and think about.
You have a fan in chat talking to you, Mark.
Oh.
Searching for truth.
Oh yes, hey there, how you doing? That's Billy. Hey Billy. I was speaking. Yeah, I was actually watching a NASA spacewalk, and I made a comment And Billy said, "You Marc?" And I said, "Yeah." And he's like, "Oh, hey." So we talked for a little while. Nice to see you, Searching for Truth. Thanks for joining us tonight. And again, his name is Billy. He's a musician. He played the drums for over 30 years. I remember that. And I respect drummers because I've been one for as long. And I know what it takes to I know what it takes to keep the skills up. So you got my respect, Billy. You got my respect. Okay. If you got any questions too, by the way, feel free to ask. All right. So this is our object, the tadpoles we just saw, and we're gonna leave this object behind now. We finished doing it. It's gonna be up on our database here, if it's not there already, in moments. And then what we'll do is we will let you know when it's available there. It'll be there literally in probably just a few seconds if it's not already available. And I know Izabela, she's looking right now to see if it's out there. So there is the tadpoles as you might see it in a pretty good telescope. All right. Let's go back here and let's take ourselves back to the tadpoles for a minute. And there we are. And now I want to take you to this other nebula right here. This nebula turned out to be amazing. The spider. It was really quite a wonderful sight. And so we're going to check it out again. All right. So the telescope is heading there now. It's right next door. But as you can see, we're screaming over there. And you'll see it in the view when I come over here. There it is. Okay. We have the spider and we have the fly. And I will move that over just a little bit so we can include both in the same image. Right? And to do that, we're going to have to go east. Okay. Move the telescope a little bit to the left. There we go. Izabela says the tadpoles and all the aliens living there are at this link. Very good. Thank you. All right. Yeah, Billy, make sure you hit the subscription button, okay? And give us a thumbs up. So subscribe, and when you hit the notification bell on YouTube, it works differently now. It's a drop-down list. You got to drop down the list and click all notifications. I don't know why. I'm sorry for that hassle, but it's what you got to do. James Dugan, how are you down in Australia? Welcome. Good to see you, man. Sorry I didn't see you right. Okay, we're stable here, so we're going to now start a longer exposure. Let's do 45 seconds on the spider and the fly. All right? So that's what we're going to do. Off we go. We're going to get out of night vision mode, jump into our stack, and clear the last one.
Fantasy has a question.
Okay, this is the last one we had. This is the tadpoles. There they are. And those are just stunning, huh? Gotta say. All right. And again, for those wondering, the feature we're talking about is right here. Okay, these are the tadpoles right there inside this, all right? Okay. And now I'll get to Fantasy's question. I'm just going to clear this now. Fantasy, what's the question? It says 90% of the stars are M stars. If you look at that last image, and everything is so bright. Why is that? Well, actually, the reason that's so bright, Fantasy, is because sometimes we see lots of M stars and sometimes we see very few. When I zoomed in, well, that's pretty. When I zoomed in on that early on, okay, or when I zoomed in and talk about the potential life around one of the planets, the star that I was actually pointing to was probably an M star, actually. And if we zoom in, we still have a little noise in here, but if we zoom in, the M stars will become apparent as we get closer and zoom in. Because right now, the brighter stars are taking all the glory away. But check it out. All right. Now here we are. All right. Okay, it won't stop. Don't stop. Okay, we're just like going in too far here. All right, here we go. So let me show you this. Okay, so now when we come out, all right, See, we have some noise. You'll see a lot of that noise go away in just a few seconds here. All right. All right. Yeah, see? Okay, so now, all right, so now when we come in, all right, take a look.
The M stars will be those little red ones,
See
probably.
one? Yeah, they are. See, so these little tiny stars, they're in here. They're just lost amongst the much brighter ones. There's one. There's two or three. There's one. There's a bunch of them right there. There's one, and there's one there. One here, one here, one there, one there. You see, you can't see them. They're so faint that even with the telescope, you really got to look for them, you know? So that's kind of what's happening here. The universe is a vast place, and I am telling you, it's just incredible. I'm going to process this now to look a little better, so I hadn't done that yet, so let me do that. Here we go. Okay. Let's zoom out a little bit. And I'll bring this in a little bit. Okay. Bring the black in just a little bit. Like this. Just darken it up just a tad. This is our black level, and when it intersects the top of the curve, it'll make space as black as it should get. If we're just to the left, that's just about right. I'll color correct now to align the curves. Now the curves are aligned, and the colors here now change more realistic. You can now see more detail because we've aligned the curves properly. Oh yeah, Ray. Yeah, this is not that, but that's the wrong object, but that's okay.
And you see 6537 is in Sagittarius.
Yeah, so that's a summer object. So here's the Fly, and here is the Spider, and it's called the Spider because when you examine it, you see there's tendrils here of material coming out, and those tendrils are really cool. They look like spider legs, kind of like Daryl sees in every image regardless.
Oh, I see him right now.
Yeah. Wow.
I've always wondered how much of that's real and how much of that is, I don't know, is artifact of the image or what.
Or your brain trying to make sense of it.
Well, yes.
Okay. So, as you can see, by the way, I hope that answers your question about the M stars. They're there. They're just subdued. They're the lowest luminosity objects in the entire universe, right? Except for, obviously, brown dwarfs and things like that, which aren't stars. But you see that they're very small. They're like, sometimes they're 0.01 times the mass of the sun and 0.2 of the size of the sun. And the luminosity or brightness that we see on an image for a star depends a lot on the radius of the star, all right, and the temperature, all right. Now, it depends on the square of the radius and depends on the fourth power of the temperature. So the radius of a star has a big effect. So the bigger the radius, the larger the luminosity or the intrinsic brightness of the star. That's what that means. So that's actually, pretty significant. Like the luminosity is like 4 pi r squared sigma Stefan Boltzmann constant t to the fourth power. Okay, and that t is the effective temperature. It's called. So fourth power of temperature, second, the square of the radius determines the luminosity. So fourth power of a very low temperature star, not so much. Square of a small radius star, not so much. So the overall luminosity is not high. So you can see how stars like that are not very luminous in general. Okay.
Isn't Barnard's star also a red dwarf?
I believe was gonna say it's not a carbon star. That would make it a giant. So it might be a red dwarf, but I have to look it up.
Well, yeah, Barnard star, the one that's
Yeah, it's in near the elephant's trunk.
moving
that's
so
that's
fast.
no, sorry, that's the garnet star. Sorry.
Oh, well, yeah, Barnard star is the one that's moving so fast in the
Yes.
sky.
We've actually seen the movement of a star in the sky. We've actually tracked Barnard star over the course of like 5-6 months. You can see that it has changed position. It's really kind of freaky. Let's see. Michael Hedrick says, Mark, can we talk about how long it used to take to get one photo like this in the 1980s? Yeah, sure. Let me talk about that. I got my degree in astronomy in 1983, so I'm up there. And we use film emulsion. In fact, in our observatory, the best results we got for measuring the positions of stars in the night sky for the parallax distances to the stars program was by using glass plates. They were Kodak glass plates, and these glass plates were extremely sharp. You could easily slice your hands up with them when you're holding them. They're like shards of glass, and perfectly square. And we had to use them in the cold, in complete darkness, load them into the film trays, develop them in complete darkness. And so it was really interesting. And to get images like this, okay, I'll give you an example. You guys know Messier 82, the exploding galaxy that we call it, the starburst galaxy. It's near Messier 81. Okay, Messier 82, we capture here in about 10 seconds. To capture it like I captured it here with those glass plates, and I did, it took an hour and 45 minutes of guiding that telescope by hand to capture it in the same brightness. So to say we've come some leaps and bounds is an understatement, right? Outstanding.
Barnard star, by the way, yes, it is a red dwarf.
Yeah.
Spectral type M4, too faint to see without a telescope, and it is the fourth closest star to us after the three stars in Alpha Centauri.
Right. Now, is
it's in Ophiuchus.
An M4 Roman numeral 5, right?
All I saw was M4.
Okay, because an M4 could also be an M4 1A, M4 2, or M4 3. It could be a giant star.
It's a red dwarf.
Well, not all M stars are red dwarfs. That's what I was getting at.
Well, fine. All I'm saying is it's a red dwarf, spectral class M4. M4.0V.
Okay, so it has a V after it. That's what I asked. Right?
Yeah.
Okay, so that means it's on the main sequence. So it is called a dwarf. It's not a supergiant, for instance. Can you look up the garnet star and see what that is? I thought that might have been a giant.
It's Herschel's garnet star, isn't it?
Yeah. And find out if that's it'll be an M star, but then you want to find out if it's a supergiant. It might be a dwarf, but I don't know about that. I think it might be a giant. Something tells me it was a giant.
It's a red supergiant.
There you go. Okay, so that's a 1A or B. I mean, what?
Spectral type M2E1A.
Okay. E means emission. It's actually got a cloud around it of emission lines, so it's losing mass. So that gas gets left off the star, but then something is exciting the gas to glow, and so we get emission lines with it. That's I think what the E stands for. That's a little e, right?
M2 small e, 1 small a.
Okay, yep.
I assume you're talking about the garnet star in Cepheus.
I am.
Yeah, Mu Cephei.
Yeah. Okay, this is beautiful. This
Red
is
supergiant or hypergiant star.
yeah. I was confusing that with you know, with the other stars. I like duh, you know. All right, so let's back out of this and go check out the entire frame. Yeah, so there is our spider and the fly. Wow. This down here is the beginning of the tadpoles, and up here leads us to the next object we're going to go to, which is the Flaming Star Nebula. These are all three in the same region. Okay, this is 16 here. I think this is good for here. So we're going to pause that now and change the name. Spider and fly. Not flu. Fly. And these are EN, emission nebulae. Alright, and now we can save them.
Herschel's garnet star is 19.2 solar masses.
Yep.
Radius is 544.7 million miles.
Yeah, it's huge.
1,260 solar radii.
Is it on the asymptotic giant branch, the AGB?
I don't know.
Okay. I didn't know if it told you. Alright, cool. When the star uses up its hydrogen, it becomes a red giant as the core contracts, and the outer, now it gets hotter and more radiation flows out as the core contracts, gets hotter. So the star expands and it leaves the hydrogen fusion part of its life. And then if that core contracts enough, it'll begin fusing helium into carbon, because helium is what the hydrogen fused into. It makes the helium into carbon, and then that comes that's called the horizontal branch. It comes back, and it starts to get a little bit bluer, and moves back and stays about the same luminosity, kind of comes back a little bit. Then when it runs out of the helium, the core contracts again, and it begins burning in shells around the center, and it begins to bloat again, and now it comes back and goes up to be a red giant again. So stars in general become red giants twice in their lifetimes. And that second time is called the asymptotic giant branch, because that's a branch that parallels the original red giant branch, and that's an asymptotic, approaches and parallels rather than crosses. It doesn't cross, it approaches and parallels. So it's an asymptote. So we call it the asymptotic giant branch, or the AGB, and that leads to the final demise of the star after that. All right.
Anyway.
Sorry, you didn't like that?
Well, but
I mean, that's what it is, right? I was just curious. All right, so so I saved this, okay, and so now we can get rid of this, I think. I did save this, right? Izabela, check on the server, please, and make sure that these are there before I kill it.
Did you name it?
I did, and I think I saved it after that, but she'll check for us.
It's still running.
Well, it's. See, I have resume. I'd paused it.
Izabela, we did some tinkering before the show tonight. That's why we were a little bit late.
Yeah, actually, I lowered my value and raised his way up, so it matched our levels, and he raised his level at his end. So we're equal, all right. But we're also we're equal, but we're also lower overall. Okay, so the spider and fly is out there. Thank you. All right, so we're gonna clear this now and go to our night vision mode again, and this will this will take us, all right, to here. Oh, beautiful. I mean, it's almost fun just to cruise star fields in night vision mode sometimes, you know? Just to look at what's out there. So now we come back here, and the last place I want to go in this region is a little bit over here, and this is the Flaming Star Nebula. You'll notice these are all in the same region, and we've done a mosaic of this whole region where you can see all three in one image. We're not doing that tonight, but we kind of could, I guess, but we're not going to. All right, so we're going to go there now to the Flaming Star. The Flaming Star offers its own interesting beauty because it has a emission nebula and reflection nebula and dark nebula all mixed together. And it's really, really cool. So let's wait. Here it is. You can see the tendrils already. And we're going to head west a little bit. Okay, like that. And then we're going to drop south for a bit and to get some of the southern region. Yeah, I can't wait to see the comet. It's going to look pretty cool. All right, so there we go. Okay, so it takes about 14 seconds for our guide star to be captured over there. And I'm going to make this a 45-second shot. But before I do that, actually, I'm going to do something else. I'm going to just do one quick view. I'm going to drop up to 250% and check the focus. Make sure the focus is good. I did use the focusing system earlier just to make sure that we're good.
Good night, Tara.
Oh, Tara's leaving us?
Yeah.
Okay, Tara. Thank you so much. Thank you very much. Good to see you today and tonight. Okay, we're good here, so we're going to drop back out. All right. Alrighty.
James, considering the difference in latitude between me in Colorado and Marc's observatory in Arizona, it's above the horizon for me right now, though still quite low. And I'm not sure it even is above the horizon yet from Arizona's point of view, since he's farther south. It might still be below the horizon.
Yeah, it's definitely not. It's not ready for prime time yet.
Yeah.
But it will be. It's moving very fast. We'll be able to see its motion in the sky, one photo to the next, and probably in as little as 5-10 minutes even. Because we've seen that for Comet Neowise. We could actually see its motion change over the course of 5 to 8 minutes, and we did a GIF of it moving through the sky.
Mm-hmm.
Yeah, and this one's moving faster.
Yep. Some comets are like that. It's going to pass over the North Celestial Pole, Polaris, and Yakutake did that, and seen other comets do that.
Yeah. Oh, look at that. Oh, see, now this is beautiful. Let's,
Those four stars at the lower left, the two pairs, those are the same ones I remarked on earlier, didn't I?
I'm sure it was, because this is the tadpoles right here, the edge of the tadpoles.
Yeah.
Yeah, and there's another one here. Actually, it won't see it now, but if I move this down, it's just out of the view. But we're going to maximize this and just watch it come in. So let me bring that over. All right, there we go. And now we'll zoom in a little on this. Okay, this is what I was talking about. Check this out, guys. This is really an interesting location because it's a confluence of a lot of dark nebula, right, which you can see in here, all right, and you see hydrogen emission going on in here, and this blue, this is also dark nebula, but it's dark nebula that is scattering the blue light from the stars, and so it looks bluish because it's scattering the blue light. So it ends up looking blue, but it's actually basically delineating where the dark nebula is with light. Very interesting. And so this is what's called an emission reflection nebula. Emission and reflection. And to Donald Kunzer, it says, look, it has veins. It sort of does. These blue lines do kind of look like veins, don't they? If we zoom in on this, right, you can see even more detail in these areas, because you'll see that you start to see even more subtle variations, right? So right in here, look at this little tiny triangular variation right here, right? Nice stuff. And then look at this. You have hydrogen emission on this side, right? And you have dark nebula over here. You know? So having dark nebula on one side or the other, it actually makes a shaped piece out of this, you know? So that's neat. So let's try and do just a little bit of processing to kind of soften the noise a little. All right, there we go.
I know we
I can see that better.
we did a mosaic of the flaming star, the tadpoles, and the spider and the fly.
Yep.
Weren't we missing a couple of bites out at the ends?
Yes, we were.
Yeah.
And I actually went back another night and I filled those in, and then I never came back to process them again. Hey, Calabos, how are you? How are things at SpaceX? Good to see you, man. Yeah, so we're doing good here. Okay, Izabela says, a dark nebula scatters light. Does it mean it has a different chemical composition than an ordinary dark nebula that looks blackish? Actually, no. It's just that if starlight is coming into these tiny grains, right? These tiny grains of material that make up the dust, then the spectrum of all the star's light hits these pieces of dust, and what happens is the blue component in the spectrum is the most easily scattered by these small grains. In fact, the James Webb Space Telescope just took a picture of a distant dust and debris ring around a particular star, and when it did, it saw that in the shorter wavelengths of the infrared, that the dust was actually brighter. And what did that mean? It meant that the dust being brighter, it was more efficient at scattering, and it told them how big the particles were. And it's the small particles in the micron sizes that will scatter this light, like you see right here, very efficiently. So this blue light is scattered by small micron-sized particles of dust. And it's that dust that exists all throughout this nebula. It's not just here. It's here, it's here, it's all throughout there, but there's just not a star nearby at just the right angle, just the right location to have its light scattered by that dust. So where there is, you'll see it, but where there isn't, you won't. And so it's sort of how that works, right? But it tells you the size of the dust grains by the nature of the scattering. Now, can there be larger dust grains? Sure, there can. But in a nebula pretty much has a composition that is going to stay relatively the same over certain amounts of distance. So if it's scattering here but not here, okay, it means like here but not here, then it means that this particular location might be farther from us or closer to us than this location where there's dark nebula that's not being scattered. So again, it's a 3D universe. We don't see it in 3D. We only see it as a projection on the sky plane. So I hope that makes sense to you, Izabela. Yeah, Calabos, I'm glad things are going well. I'm glad you have payday coming up. But it's nice. Cyclone, nice to see you. I see you there. As we move forward, I will be happy to talk to some more Calabos about SpaceX plans for their future. That's pretty. So this looks really nice. I have new respect for the flaming star. I really do. I never liked looking at it. I thought, well, I don't know why. You know how certain nebulae strike you as really cool. Can't wait to see them again. And some nebulae, you just like, eh. Okay, this was one of them. Except after doing that mosaic of the flaming star with the tadpoles and the spider and the fly, I had a whole new understanding and a whole new appreciation of this nebula. This is an extremely complex location. Very complex.
Especially when you take the wider look at it.
Yeah.
Such as on the mosaic.
Yeah, I agree. Hey, Sean Paris, how are you? How's it going?
Can we look at Stellarium real quick, just to see where we are in the sky looking at this?
Yeah. Let's back out. And you can see we're in Auriga. I know you know that, Daryl. Just
okay.
There's Capella and the kids right there.
Yes, very good.
All right. And here is Auriga in the mythology. And that's really nice.
Okay, thank you.
Mm-hmm.
We're sort of between Capella and El Nath.
Yeah. Let's I'm going to go back up here.
Drinking again, Mark?
No, I'm just trying to get here. Let me find out where that's sitting. I was thinking we might look at the Andromeda Galaxy.
Yeah. It's still up fairly high, but it is getting over in the west now.
Yeah, it is. So I figured we'd do the Andromeda Galaxy, followed by the double cluster, and then move on from there to something new. All right. So here, let me just do. Let me just take the flaming star. All right. And first, let me bring back our telescope here, and then went to our stack. And right now we have got 14 stacked. That's pretty good. We'll pause it, save it, and then save it exactly as seen. Alright, and then we'll get out of that and go back into our night vision mode. There we go. All right. All right, so now what we'll do is come back into here, into our stellarium, and we'll check out the Andromeda Galaxy. Watch the telescope, folks. It's going to swing over to the left. Here we go. So watch. There it goes. All right. It's making its way over there. So it's going to be stopping any second now as it heads over there. Yeah.
Yep.
It's stopping.
Yeah. Oh, it should still be high enough to see. I know.
Yeah.
When I did the, when I took pictures of Hale-Bopp back in March of '97, Andromeda was still up, but it was over the western horizon. And
Yeah.
It showed up in the same camera field of view as
Wow.
the comet did.
Wow. Well, this will be fun to look at because it'll be kind of like one of the last times we'll see it for the season. You know, because it'll be kind of too low to look at later. But this is Messier 31. This is the galaxy Messier 32, an elliptical galaxy. And this is Messier 110. And I'm going to raise this up just a little more because I want to be able to catch the beautiful, hot blue stars down here in the spiral arms of galaxy. These will be off the edge, but that's okay. It's a big object. All right. So we're going to let this stabilize, let it get its guiding. And there we go. It's calibrated to zeros, and now it's doing this. And we'll do a 30-second shot of this. All right. I think we're stabilized now. So off we go. And then I'll change this. This is Andromeda Galaxy. And we'll go into the live stack. And once we get in the live stack, we'll remove the last one. And we will dock it back here. All right. And now in just 2 seconds, we get our image, and there's more down below here. All right, so let's now take this and we'll color correct first. And now I'll offer up the processed image for one stack, one shot. Boom. Ah, look at that, guys. Always a pretty sight, isn't it? Always a pretty sight. Now, there's a reason I'm doing this, okay? Because one of the things we can do is we can look at all the images of Andromeda we've ever taken and do a comparison and see if anything's changed in the Andromeda Galaxy. So we could find, for instance, we could find an amazing supernova in the Andromeda Galaxy for all we know, but it gives us a chance to do some real research.
Mark, excuse me just a moment, please.
Yeah.
Right back.
Well, we're not ending yet, so I'm going to keep that out of the way. Ah, there we go. Calabos, I just read that. That's exciting news. The Raptor program. Cyclone, no stupid questions, but you know, that isn't stupid. You know, if you don't know, you don't know. You don't know what you don't know, right? And so the answer to that is no. Out in space, there's nothing we have to worry about like that. Michael Hedrick, thank you. Thanks for coming. Izabela, thank you for putting up our Patreon. That's very nice. Let me, let's do this. Let's undock this for a minute. And let's go full screen here. Why not, right? This is it's our nearest galactic neighbor of any substantial size. So why don't we just check it out? I'm going to also just do one other thing. Process it just a little more. There we go. So, think about this. How does it feel? How does it feel to know that right now, looking at this galaxy, we could be looking at many other civilizations? And on top of that, we're seeing it through a veil of our own stars. These stars are all in our galaxy. They're up here. And the Andromeda galaxy is way out here. Over 2 million light years away. Outstanding. Hello, Dagger. OG Skywatch, how you doing? OG says, are the aliens from TRAPPIST-1 system? Actually, I do talks around the country. I'm actually, A&E is asking me to represent them out in Los Angeles at the Alien Con. So if any of you are going to Alien Con, I'll be there. Look me up. And I'm not sure yet. They might have me do a main speaker talk, in fact, too. And that main speaker talk might, if they have me do it, might be on UFO propulsion using string theory and some of the coming science that is on its way to us that we're starting to make headway in. It has to do with the CERN thrust and a lot of the Large Hadron Collider work that's going on right now. They're looking for particles that can do the kinds of things that we're talking about, and I will be able to tell you all about that, you know. But the thing is, to get long distance in space, to go there, for instance, we always look at it as like, it's going to be pretty crazy, you know. But we could do it. We could do it if we use a process that I can outline at some other time. But I'll be talking about it at Alien Con, maybe. And Caldwell says that he'll be going to Alien Con as well as Contact in the Desert. Well, I'm going to be at both, so you have to look me up, Caldwell. We have to talk, because I will be at Alien Con for the full time, I believe, and a week later I'll be in Roswell doing a talk, and then in June, I think, is Contact, and I'll be doing a talk in Contact as well. Actually, I'm also going to do a live SkyTour live stream session at Contact in the Desert. We're going to have internet out there, and I will be able to do a live stream like we do right here. And it'll be with a live audience. So that's going to be the first time. That'll be kind of fun. You know? I forgot about that. So that's going to be kind of fun. So I will see you at Alien Con probably, and I will see you in Contact as well. If you're going to wear a SpaceX garb, you know, we gotta make it obvious because Alien Con. Okay, just say those words slowly. Alien Con. You have to stand out. Actually, if you're wearing nothing and just a regular clothes, okay, you'll probably stand out like very, very brightly. So, okay, we're at 14 stacked here. 14 30-second shots of the Andromeda Galaxy. Let's zoom in now, Daryl.
Yes.
Come right down here. Okay, we have a focus issue, darn it all.
Did you ever focus? You mentioned checking
did.
focus a while back. Did you forget?
No, I had focused prior, but I can see that there's a slight focus issue. It's not actually not that bad. But when we zoom in, let me show you. See
Cosmic Ray, I assume you're talking about the big swath of O3 they saw somewhere near Andromeda in the sky.
Yeah, I talked to those guys that found it, and they're not sure where it is. I feel that it's just between us and Andromeda. It's actually in our galaxy, along with that hydrogen, diffuse hydrogen that we see. I think that's in our galaxy and not in between. And I think we're looking through it. So that O3 arc, that O3 arc is interesting because that O3, that greenish blue arc that he's talking about, that is seen kind of superimposed over the Andromeda location and a little left of it. That I think is in our galaxy, but they said, well, there's nothing nearby that can cause it. And that's a valid comment, but there's also nothing that could cause it out in intergalactic space either. So I think that it's more likely that it's something attached to our galaxy and that it's an arc caused by some process in our galaxy. And I imagine it doesn't take much. It could just be one star. One luminous star at some great distance that can illuminate and cause that entire arc to light up like that.
What amazes me is nobody ever saw that before.
I agree. I think that's kind of strange. All right, here's what I'm going to do, guys. I am going to stop this and not save it. And I'll tell you why, because I want to do a critical focus and get back to doing this properly. So I take off my T-comp over there. All right, there we are. And now we're going to purposely disrupt the focus. There we are.
APOD had a great I guess it was the same image everybody else has been seeing, the big O3 cloud in the sky near Andromeda.
Yeah.
It was interesting because there appeared to be a big H2 region there too.
Yeah, there's a diffuse hydrogen. There's a diffuse hydrogen region throughout that whole area, and it really looks interesting, And but what's causing it? Not sure, but I don't believe that it's. I don't think it's out at Andromeda. I think it's in our galaxy. I really do, because that is a galactic type process that we see in other galaxies as well. So I think it's here, and it's just we don't have a way of getting its distance yet. That's all.
Well, when we looked at SCA 33 in the past, it has some large O3 areas around it.
Yeah, and we know that those are at Messier 33, but it doesn't have these large detached O3 areas. There's nothing causing them,
Well, no, we've counted like more than half a dozen of them just on one side of M33. You called them supernova remnants.
Well, yeah, I think that's what they were, but those were in the galaxy very clearly. They were definitely in the spiral arms, born in and died in the spiral arms. So I just think there's our focus point. Yeah. All right. That's just my
No,
feeling.
well, I mean, I agree with you. I think that would have to be some big Mama Jama O3 cloud to, be comparable in size to the Andromeda Galaxy.
Yeah, and I don't think it is. I think that's actually in our galaxy. I think they'll discover the source. All right.
Makes for a cool picture, though.
Yeah, it's a beautiful picture. Okay, we still have our same field. I'm just magnified here. So we're gonna come back in here and do we'll do 35 seconds now. All right, and we'll come out of our night vision mode, come back in to our stack, and we'll clear this. And the next shot will be, the star's gonna be a lot sharper. And let's pull back for a sec. There we go. Okay. Okay. So those stars look much nicer now. And we will check this out as a whole. Beautiful galaxy. Calabos asks if I'll be at Conscious Life Expo. No, I won't. I actually have to film with A&E 4 times between February and the summer, I think, and so I'm gonna have to work on that stuff. They have me doing video analysis for them for The Proof Is Out There. That's actually why they're taking me to LA in March too. I have to do something with them. I'm not even sure what it's gonna be yet. Hey Levitus1, how you doing? Oh, Levitus1, we were just talking about this too. He's watching the stream, and then History Channel has me on doing something else. I kind of remember that, yeah, that episode. He says History Channel's playing an episode where I'm commenting on a cell phone video of a possible UFO in Phoenix. I remember that, yeah. That was pretty cool. I spoke at the Conscious Life Expo, a couple of years ago, actually. I think 2017. It was actually in Manhattan, and I drove down there, and it wasn't as good an experience as I would have hoped. I was on the 34th floor of a skyscraper to do my talk, and the entire building was swaying. Okay, very slowly to the left and right. You could feel it, and it threw off my equilibrium because over time, it's weird, seeing people moving out in your audience when they're sitting still. But I felt like I was on a ship, a very, very big ship. And they didn't have a proper projector for my presentation, and the windows went from ceiling to floor. And I was standing like right next to these windows from ceiling to floor, looking down 34 stories to the street. It's like, oh, man, that's not a place to get dizzy and fall. Oh. Calabos says 2017 was their first contact in the desert. I've never spoken there. I got a call from Victoria this year, and she said that she wants me to speak there. So I said, okay. And she then said, I saw that observatory. And I said, oh, tell me I can do a live presentation for everybody from the observatory. She says, oh, that'd be wonderful. I said, it's on. Nighttime, in Indian Wells, California, and streaming from Arizona further to the east. So that'll be cool. Very nice. Did Sean have a question that he wanted to ask?
I think he and Calabos are talking about
Okay.
the whatever program you're talking about.
All right. Okay, we've done 8 of these. What's that?
The convention or whatever it is.
Oh, AlienCon.
Can we do something while we're still here?
Yeah.
You mentioned the other night, and I know we've looked at it before, but
Here?
yeah, go up at 110 and zoom in on it.
Yeah, show you the dark dust lanes.
Yes.
Yeah, usually these don't have dust, but it's interesting that this does. Let me show you. Okay, look at the dust lanes in here. This actually has dust lanes. And elliptical galaxies don't usually have dust lanes. So, and there's one here. So there's some interesting things going on in Messier 110. Usually, though, galaxies are elliptical because they have dispensed with all of their dust and gas in the galaxy. So there's no more real star formation going on. And they're just going to basically slowly fade away and maybe have a few supernova remnants or something. But in this case, it's rather interesting that this just doesn't seem to have, it doesn't seem to have any dust. As much dust, rather, I should say. This has some dust compared to other ellipticals which do not. Like this one down here, if we go to Messier 31, this looks more like the classical elliptical galaxy, all right? Because it has like no dust in it. If we reduce that, if we reduce the look of that and dim it down, you can see that there's really no dust in there. If we take a shorter exposure, you'll see that there's no dust in there. So it's actually interesting. Okay, so let's just pop this to about here.
Cosmic Ray wants you to try to grab that oxygen cloud. He says they took it with a 4.2-inch Takahashi refractor and large format CMOS camera.
Yeah, but they were also doing narrow band.
And that's what I was going to say.
We're capturing O3, but we're using a all-in-one filter. We're doing O3, H beta, H alpha, all in one shot. And Calabos, I'm always taking requests. So when a Betelgeuse comes up, we'll look at it. And for Ray, we can try and see if we can even get a hint of that oxygen 3 location. Our sky is certainly dark enough, no doubt about it. But we'd have to. This is the size of our field too, so we'd have to move off and put the Andromeda galaxy. I think it's on the side of Messier 32, right? So it's down here, right? It's not up here, correct?
Yeah, it's to the lower left.
That's what I thought. So I gotta move this almost all the way out, if not all the way out, and do a nice deep shot of that area and see if we can get some kind of hint of it. It's big.
If you park the nucleus up toward the upper right-hand corner of your frame,
Yeah.
up that direction, you'd probably be in the field.
All right. Well, we've got 14 stacked here. We'll do the 15th, and then we'll try it. And while we're there, I'm going to do this. I'm going to say Andromeda Galaxy. There we are. And we'll take this last photo, and then pause and save it. All right, there we go. We have 15 frames here. We'll save it now. And then save the exactly as seen.
Would it help if I posted the image for you?
Probably.
Okay, give me just a second.
Meanwhile, I'll do all the setup here. Okay.
Whoop, I closed it. Give me just a second, I'll get it back. And
No problem. All right, so I'm going to put this all the way up there, and let's see if that's going to help us. So we're going to go to the east.
I'm just going to drop this in your chat, Mark.
Fair enough.
That should give you a really good idea of... There it is.
Okay. Oh, I don't know. I think we have to keep going quite a bit. Alright, here's what I'm going to do. I am going to do this. I am going to move this because it's extensive, because Andromeda is extensive, you know. We have to make sure that this is actually... Alright, here we go. We're going to go to the east. And I'm going to take it right out of the field because I think I'm going to have to. I mean, this almost looks like where it would be, right?
Yeah, you're in the neighborhood, I think.
All right, well, let's just try.
Can you identify that bright star in your field?
Me right here?
I was thinking the one up towards the top, but...
Oh. Yeah, let's try something here. I want to... Oh, okay. I think I know where it is. It is here. It's right in here. Okay. Yeah, because see that right there?
Yes.
Okay. I'm showing Daryl the photo. That's this right here.
Yes.
So it's right here?
Yep.
Okay. All right, folks. We're going to try a little experiment here. I'm going to move us to the east a little bit. And let's see if we can find that O3 arc. We do have an O3 filter in here combined with the other one. Let's find out if we can capture anything.
Nothing ventured, nothing gained.
That's right. Now, it's weird, but I kind of see something here. But we'll find out if that's real or not. All right, this is going to be a 55-second exposure. All right, wait for us to guide, get it stabilized. And there we go. It's off and running. And we'll go into the stack and see if there's anything to be seen. It'll definitely require a healthy number of images, I think, though. All right. So what we're trying to get is this. Andromeda arc. An O3 nebula? We'll find out. Alright, hold on. Let's color correct. I'm seeing a little blue color here. I'm not sure if that's it or not. I have to. Let's pull that out. We don't need that in there.
And I will be right back again.
Okay. So, this object that we're talking about should be visible. If it's going to be visible, it's going to be starting about here and kind of coming down through the field here. Now we're at 55 seconds at 350 gain. And I would guess that we have to do this with narrowband filters in order to get it. In other words, the filters we're using as a combined filter, you get some of this data, but you don't get all the best renderings of that data. So I think that we would probably have to try with a true narrowband system in order to capture this. Let's try pushing this with this guy too. I see something here. Keep in mind, it's also lower to the ground. It's also lower now than normal. So when it's that much lower, you get that much less. Clarity. You're looking through what's called more air mass. So anything subtle could get lost. We might have to wait for Andromeda to be directly overhead again to try in earnest to get this. Thank you, Izabela, for putting that up. Hey there, M. Turner. How are you?
Okay.
Yeah, Michael Klager says a mono camera and an O3 filter would help. Yeah, I mean a true narrowband imaging setup would help, but we're not doing a true narrowband setup here. The next telescope, we already have the filter wheel, and we're going to get the filters to put in it. And I'm going to have one of these filters in it, and I'm also going to have the 3 narrowband filters. All right. So we'll have what we need to do this.
A mono camera?
No, it's going to be a color camera. We can just shoot it in mono, and then recombine it. That's nothing we can't do. So I'll be able to shoot in color. I'll be able to shoot in black and white as needed. The images will be converted, in other words. Okay, this I think it's kind of low to even try this, Daryl. It really should be straight overhead to do this, I think.
Okie dokie.
All right.
Thank you for trying.
Yeah, no, it's a good idea. Thank you, Cosmic Ray, for the suggestion. We'll probably do it at a time when we can see it in a better light. All right, let's see here. All right, there's that. Let's increase to 40%. Okay, and then back here. Okay, so.
Where are we going now?
Well, as you can see, the pole is right here. I'm wondering where the comet is. Did they tell you? I know I can't see it, but
It's
Is it near Kochab?
no, not yet.
Okay, so still wait
It's
down there.
moving from Booties into Draco right now. It's in
Okay,
Booties, strictly speaking.
okay, so it's,
Go right down to the northeast horizon.
yeah, yeah. That's Draco. Okay, so this is Draco here. So we're gonna be over here more. Miser, there's the Big Dipper. Okay. All right. Well, it's not ready.
Yeah.
It's not done yet. However, we've been going long enough so that now we can go check out other things. What's this guy? I forgot. Oh, Caldwell 7. This is an SAB. Barred Spiral. We can look at that. Let's swing the telescope all the way to the other side of the sky. Here it goes. Alright. See, there's Caldwell 7. It's a pretty galaxy. I want to check it out. That looks pretty, huh? Look at that. I was hoping we could check out Hubble's Variable Nebula here again. It's not here, but you know, we're waiting for.
The one in Monoceros.
Yes. Just have to wait for that. This is going to be a pretty image. This will be really pretty. And as always, you know, when you take a picture of what you think is one galaxy, you might find more in the same field. This could be similar. We'll find out. We'll do 25 seconds on this. And we're going now, so off we go. Out of night vision mode, back into live stack mode. Clear the last buffer. And there we go. Okay. Hey there, Luciana. How are you? Alright, so let's check it out. So let's adjust the curves. Wow, look at that. Adjust the color. That's really pretty.
It is.
Alright. That's really pretty. Very nice. Look at that. Beautiful spiral arms. This is a barred spiral from what it says. It's a tightly wound barred spiral, SAB. Very nice. Look at that.
Mm-hmm.
I think there's an H2 region right there. Look at that.
Yeah.
Oh, Caldwell 7. What a gem.
Well, there's some very faint stuff to the upper left of it.
Oh, right there, you mean?
Yeah.
Yeah, look at that.
It's a nice little galaxy.
Yeah, I'm glad we chose it for a second here.
I think it's Caldwell 7, Izabela.
Yeah, it is Caldwell 7.
Could we look at Stellarium for just a second?
Yes. Let's go in there. Let's
And back out just a little bit. I think you're right up above M81 and M82, aren't you?
well, I don't know about that.
Yeah, right there.
We might be able to see them.
I know.
We can try.
Ursa Major's still pretty low.
Yeah. I think we'll be able to see them. We can try after this. Okay. Look at this. This is really pretty. What a little gem this was, huh?
Mm-hmm.
All right, let's take this down a little bit. Just zipping through here to see what's good. Notice the blue spiral arms. Look at this beautiful, these beautiful clusters of hot young stars right there. That is exactly what we expect to see in spiral arms. Is like these little tiny areas right here. Okay, see those hot blue stars in there? It's got a strange bar here, which is really interesting. I like that. All right. And then Daryl was talking about the faint stuff that's out here. There's an H2 region right in there. And an H2 region that's in here. It's pretty clear. Wow, that's neat stuff. Very neat. Wow, that's liking it. I'm liking it a lot.
Oh yeah, that's a pleasant picture.
Yeah,
that's a good bit of detail in there.
Yeah. Yeah, so let's see if we can coax a little data out of here a little more. Oh, look at that. Look at this. Look at this beautiful stretch of arm here.
Mm-hmm.
That's interesting.
There's
right there.
Kind of a dark band down at about 5 o'clock from the nucleus, and there's a bright feature next to that dark band too.
Right here?
No, farther out.
Down here?
There's the bright feature just to the right there.
And there's a dark band?
And that's the dark area right there.
Okay. This looks like a fan-shaped detail right there.
Mm.
Of course, we gotta zoom in to see that, so why don't we do that?
Actually,
right.
a good bit of detail in there.
Yeah. Look at that.
Nice.
That's a strange little detail. And here's a bright blue area. This might be a supernova remnant, possibly. This red thing is an errant pixel. So is that one.
I have several, look like H2 regions there above and to the upper left of the galaxy.
Yeah.
Upper right, upper right.
I see one that looks like it's here, maybe there. There's one that looks like one here. Maybe,
Let's
as you
see.
said, upper right.
Yeah, 4, 5, or 6 of them.
Yeah. Very cool. It's really nice. Let's see if we can darken this up. I wonder if this is a hot stellar formation region, like OB association, because it looks like we got some there with some nebulae in it.
Yeah.
Got some there. Very cool. Wow. Outstanding, man. That's outstanding. Very nice. Okay, well, we've got 18 of these. And we'll hang on to those. And we'll pause it and we'll save those.
That's a nice galaxy.
It is. I'm glad we did it. Save exactly as seen. Alright, now we want to compare and contrast this to Measure 81 and Measure 82.
I'm wondering if those might not be below the wall.
We're going to find out. I was looking at the height of them, and as long as they're level with Polaris, we can see them. Because I can see Polaris and a little below Polaris, of course, because the telescope has to be able to point at Polaris. Alright, so let's do this.
So why don't we ever look at Polaris?
I don't know, because it's just a star, it's a double star.
It's a nice double star.
It is.
A lot of people don't know that.
Yeah. Maybe one day we'll look at Polaris. I don't want to right now.
I didn't say right now.
Okay. Alright, so here we go. So there it is. Alright, so let's go do that. We'll go to M81 and check it out. M81's beautiful. Off we go. And you'll see the telescope will swing away here. And it's going to be right at the limit, but it'll be fine. We should be able to see it. Because now it's going horizontally. There it is. And we go north to see M82 anyway. Well, there's the other galaxy that's in the field. You know?
Yep.
Alright. So, there we are. So let's go north a little bit. And go west a little bit. There's M82. And we'll center them up and...
Interesting. M82 is showing color with a 1-second exposure.
Yeah. Well, that's a very bright starburst formation in there.
Yeah.
So that's pretty neat. Okay, so we're going to drop it over a little more. In order to take a picture, I'll raise it up a little bit because M82 has some really neat stuff. And I can get both in the shot. This puts them both in the shot. And we're going to just move the telescope a little bit to the west. All right. There we go. And where this stays, I want to do a longer exposure on this. So I'm going to do a 45-second shot here. All right. After we get our guide, so the guide is just kicking in now. Michael Kliga says, Polaris, it's only good for star trails. That's funny. All right, so now we'll get out of our mode here. Go into our stack. Clear the last beautiful Caldwell 7 shot.
I read somewhere recently that M81 does not have density waves.
Yeah, it's interesting. If that's true, the density waves can be responsible for the spiral arms, but they're not necessary. Spiral arms can be induced by interactions with other galaxies too.
Yeah, M82 in this case.
Yeah. All right, so let's float that, get that down. Look at that. That's beautiful. Now you might say, well, that's a little too bright. It is, because as you can see, our curves. This black should be more over here. So let's let it decide first of all, and then we're going to get that. And then we'll color correct to blacken up the space to make it look the proper color. All right. And now, look at that. I mean, what a complete picture. And it's like, we also see this. This is what I wanted to get with M82. I knew it was going to blow out the center, but I wanted the spires of red emission gas that's coming out of the central part. And there it is. See it? M82 has these spikes coming out of the north and south of the middle. All right, let's.
I remember back in the days of film, those red areas in M82 never showed up very well. So one of the things that seems to have become more easily visible with digital cameras.
And the CMOS, huh?
Yeah.
All right. As you can see, the whole center is blown out over here. So let me raise this up. Okay, and let's do this. Let's take this, and we're gonna move this down.
Usually we wouldn't bother with
look at that.
M81, M82 until springtime.
I know, huh?
Yep.
But look how beautiful this is.
Yeah.
It really looks pretty. You can see a lot of detail in there.
Yep.
So we're going to call this M81, M82. We should have said M81 in there too. Okay, we'll do M81 dash. Oh, I typed M82 twice? I did not. But apparently I did. M81 dash M82. There we go. Look at that. That's just something, huh?
It is.
Look at that. How pretty. And now, by contrast, right, if we slide up the ladder here, we have this guy, and with these spires coming out of the top and bottom, I mean, this is really, really impressive stuff. This is one peculiar galaxy. Indeed.
Imagine if you did post-processing, you could really pull those the red flares out.
I think I'm going to let this one percolate. We've got 5 stacks so far, coming up on 6. And so, where does it think it wants to put the processing? Yeah, that's what I thought. See, we see this out here. Was this a... Did we find this to be a dwarf galaxy that's associated with this, or did we not? Do you remember?
I don't recall offhand.
Okay.
I think it is. The one out at the lower left?
This.
Oh, that. I'm not sure.
Okay. Okay, so let's pull this way down. Look at it. See, they've got a lot of dynamic range here. Yeah, Ray is correct. The M82 is really undergoing a prodigious star birth for Ray, and that's why it's called a starburst galaxy now. This galaxy is not quite face on. It's kind of like this to us. If it was face on, it would be like the whirlpool, but it's sort of at a little angle. M82, as Ray points out, might be more edge on to us. And this one's a slightly less than face on.
Well, M82 is considered.
I mean M81. Sorry.
Yeah, I mean this is M81. M82. All right, you got me confused now. The other one.
M82.
That is considered an irregular galaxy, isn't it?
Yeah.
I mean, it's not necessarily a spiral.
Correct. At least nothing we've seen so far shows us. It probably started life as a spiral galaxy, but in interactions with M82, it may have actually had a close approach and got warped and changed.
Yeah.
Which actually could have caused the starburst formation.
Yeah.
That Ray is mentioning as well as others. Yeah. Very neat. Mm-hmm. So guys, make sure, if you're interested in seeing pictures that are totally processed to the hilt, for the entry Patreon at $5 a month, the cost of a Starbucks coffee, you will get a shout out from us. For $10 a month, you actually get access to 4 of our highly processed images per month, and they'll rotate through. For the other tiers, you actually get access to all of our highly processed images as well. And of course you get some swag as well. And Caldwell says, since we're gonna be meeting at some point, I got Tiffany to jump in here finally. Okay. Well, hello Tiffany, how are you? It's nice to meet you sort of indirectly through Calibos. Yes, we will be seeing you there at Alien Con. Yep. And there's Tiffany. All right, Tiffany Echo. Tiffany says hi, everybody. So show the love. Okay, we're at 11 stacked here for this. Let's go back and see what this galaxy looks like up here. Okay. Oh, look at that. Look at those beautiful jets. Look at that.
Yeah, it's starting to come out now.
Really starting to show up nice. This is why stacks are so important. You get rid of the noise, and you end up seeing just the data. Alright, can't wait to process this. This is going to be really pretty. Wow. This is good.
For this early in the season, too.
Yeah. Okay, we're going to pause this here at 12. No, not yet. I'll let it do 13. 13's lucky. 13 was the number of my last house. 13 Oak Street. What kind of scientist is Tiffany Calabos? Don't say rocket scientist. Hey, cut that out.
I heard you yawn a minute ago.
I covered it up.
Sorry,
A mad scientist. That's see.
This one snuck up on me.
It's all right. Tiffany's a mad scientist, all just so you know. All right, mad scientist. I guess you can call me a mad scientist then. Michael Klagas has been wanting to do this target, but my apartment blocks most of the north sky. That sucks.
Vera's here. Hello, Vera.
Vera Lucia Campos, how are you? Are you from Brazil? I think she's from Brazil. Nice to see you, Vera. I actually formulate and fill antibodies that detect cancer in patient biopsies within 24 hours. Oh, okay. Very good. So Tiffany's in the medical field. Nice. Hey, Vera. Thank you. That's so kind.
Thank you, Vera.
So nice to see you, Vera. I haven't seen you for a long time. Okay, we've got 15 stacked here, and this is good. All right, so we're going to pause this right now. All right, it's paused. And now we're going to save it just as it see it. We're going to save this file and save the file exactly as seen, and then we'll get rid of this. Alright, and go back into our 1 second night vision mode. Okay, zoom out a little. Okay, and let's go see what else there is. Alright. Now let's head over here. We haven't seen this for a while now. And I think this is high enough for us to see. What is it, you may ask?
Oh, the Beehive.
It's the Beehive Cluster, yeah. Well, Caldwell says, well, Tiff thinks I'm insane. Well, then, maybe you are. Shh.
Hello, Vera. I missed you. Everybody missed you. She just wants to hear my voice. She likes my voice.
Wonderful.
Didn't Elton John say that Mars ain't the kind of place to raise your kid?
Yes. In fact, it's cold as hell.
Yeah. Oh, thank you.
So here's the Beehive Cluster. Let's do a 15-second shot of the Beehive and check it out. Go live stack it. Clear the previous. Alright, and do this and color correct. No light pollution on Mars. Well, actually, may not be true, Michael Klages. No, there won't be lights like we have here. But it turns out Mars may be responsible for the solar system's zodiacal light, the afterglow of the solar system, the dust that we see sometimes. 2 times of the year we see it slanting up from the horizon. That's the dust in the solar system backlit by the sun. And it turns out that Mars might be the culprit for much of that dust. So Mars might actually have a fairly dusty environment around it. So we don't know.
Well,
Maybe.
How is the dust getting off Mars?
Oh, from massive collisions on Mars that have occurred in the past. Collisions that may have helped to expel a lot of the atmosphere that was on Mars, along with other things.
Okay. So, like, it's not like solar wind or anything.
No, it's actually from collisions. Yeah. Sam S says, Mars ain't the kind of place to raise potatoes.
Ray, that's true. The beehive is, one of its other names is called Praesepe.
Yeah.
And it was known to the ancients, along with a few other bright deep sky objects.
Donald Kunzer also says, strongly recommend the movie Robinson Crusoe on Mars. Me too. That was a very, very good movie. I liked it.
I liked that when I was a kid, yeah.
Yeah. Oh, Ronald's back. Hey, hi, Ronald. Welcome back. Yeah, he says, Donald says, the best part is you can take out Mars and make it any planet, and it works. Except Earth. And by the way, hello, PG. I don't think I said hi to you earlier. I apologize. That's Petita in Pennsylvania. I've seen Petita a couple times in Pennsylvania. Now she would come to Pine Bush. I won't be in Pine Bush this year, Petita. I'm sorry. I would have been, except I was invited to speak at Contact in the Desert out in Indian Wells, California, and at the same time as that conference at Pine Bush. Sorry, but it's all good. There's a lot of things going on. So Persepi's looking really pretty here. And I didn't want to do too many. We got 16 stacked. That's more than enough. We'll pause and save it. And I'll name it. This also the Beehive. I've grown up with it as Persepi. That's how I've known it. So I'm going to call it the Beehive, though.
Oh, yeah.
It's an OC, an open cluster. All right, so I'll say save. Save the raw. Save exactly as seen. And then get rid of the stack because it's been saved.
Yeah. Izabela, yes, Robinson Crusoe on Mars was sort of like a precursor to The Martian. Sort of a similar storyline. It was about a an astronaut marooned on Mars and how he survived.
Hmm.
Oh, that was a long time ago. That must have come out early 60s maybe, or even older than that.
Well, yeah. I mean, weren't they using like Chesley Bonestell to do like the matte paintings of the Martian
I
terrain?
think you're right, yeah.
And he was a fabulous artist and fabulously wrong about what it looked like because we didn't have the pictures.
Yep.
We hadn't visited. So that was what everybody thought it looked like, and that's okay. I just thought it was pretty cool.
Oh, I loved the movie when I was a kid.
Yeah, it was a really good movie. I'm going to do something crazy. I'm going to actually see if we can go to...
1964.
Yeah, you were right. I was 4 years old when it came out. All right. I'm going to try to go to M78, which is right there near Orion. I don't know if we can see it yet. It looks like... Oh, no. I think we can do it. I think it's high enough.
M78.
I'm rushing. That's what I said. Yeah, Measure 78. So we're going. And I think we're going to have no problem seeing it. I think Orion's well placed right now. There we go. Can't miss it. Look at that.
M78, remind me.
Casper the Friendly Ghost.
Okay.
Izabela wants to know if there was a Man Friday
There was.
on Mars with him.
Yep. And the monkey. The monkey's name is
I remember that.
Barney the Woolly Monkey. Adam West was in that movie too. I hardly remember that.
Really, what did he do in that movie?
He played Colonel Dan McReady, McReady,
Yeah.
whoever that was. I don't remember that.
All right. Okay, we're gonna move this over. This is a beautiful nebula that actually doesn't have any real emission nebula in it per se. This is all reflection nebula you're seeing. That means scattered light of these stars being dispersed by the dust, the fine dust here. But over here, you're going to see a reddish nebula, and that's going to be part of what's called Barnard's Loop, and that's a giant remains of a supernova that was thousands of years ago, tens of thousands of years ago, and it was you'll see the remnant of it here. But we're gonna actually just do one quick thing here. I'm gonna bring up this AllSky, and we're gonna take one shot, see if our sky is still clear, and we're doing a 15-second shot here. Okay, north, south, east, and west. East, you see the lights of Phoenix that are over 65 miles away. And the sky is stunning, so we're good tonight. You don't see this with your eye. This is just on the very sensitive cameras. All right, so now that we're guiding and everything is fine, we're going to go and do a 45-second shot here. And we're at 350 gain. So here we go. Off we go. And we're going to jump in here. Do our stack. That's a beautiful cluster. Persepi's beautiful. So that's up there now, I'm sure. And now we've got Casper the Friendly Ghost. The The first thing you're going to see is you're going to see those reflection nebulae pretty bright, but you're also going to see dark lanes and dark nebulae because there's lots of that here. I mean, lots of that nebulae all through this region. So get ready to look at it right about now. Wow, look at that. There's the red of Barnard's Loop up there starting.
Mm.
And let's do a color correction. Let's get our curves lined up. Then do a proper view here. Now you can see all that dark nebulae. Isn't that stunning? And we're actually, you know, I'm zoomed in just a little bit. If I go back to what we should be, okay, that's the full frame. But look at that. There's edge of Barnard's Loop. You can see all this detail here. And as we're stacking and stacking and stacking, this dark stuff is going to start rising to the top and become brighter and more defined. All right? So even after 2, you can start to see the little fingerlings of dust down here that are defining this region. Very cool. It's such a beautiful region. Our colors are good.
I remember now.
What?
I remember now. M78, the Casper.
Yeah.
Area.
All right, we'll pull this in now. But you see immediately after just 3 stacks, you can see how this red nebula extends all the way in here, and the dark nebula is kind of mixes with it. You'll see that mixing going on all throughout our Milky Way. That stuff is all permeates our Milky Way. What a beautiful image. This is really pretty. And it's called Messier 78. It's a reflection nebula, RN. And there's little things that are really cool, like down here. Like right here. Look at that little guy right there.
Mm-hmm.
That's a very interesting location. Yep. Ray's given some facts to all of you about Messier 78. I do want to say, you know, and this is something that I wish didn't happen. They call these reflection nebulae, but it's not reflection. It gives the wrong impression. Ray's just repeating what they say out there for these. But if you really want to say it right, it's a scattering nebula. When you look at the molecules in our atmosphere and the sunlight coming in, the sunlight has all different energy levels of light. The bluest light is the highest energy. And high energy is very susceptible to being absorbed and re-radiated immediately by atoms in our atmosphere. And so the blue light coming from the sun is generally absorbed and re-radiated, where the rest of the light's allowed to pass through relatively unimpeded. And that re-radiation of that portion of the spectrum causes our sky to be blue, okay, everywhere we look, right, even away from the sun, because the molecules are scattering in all directions. They're scattering that light in all directions. Well, in this nebula, the same thing is happening. The clouds of dust in here, you notice those are blue in color. These are really stunning. Holy cow! These clouds are dust of very fine particles, which also scatters high-frequency light very well. And we're seeing it happen here, and it's blue for the same reason our sky is blue. And it's a scattering process with a special name. It's called Rayleigh scattering, named after Lord Rayleigh. All right, so this is a beautiful This is really coming out nice. And as promised, you can see how these dark nebulae are starting to really be well defined. Oh man. This is really something, Daryl.
Uh-huh.
Tiffany, I look forward to meeting you too. I hope you have a good night. You and Calabos, we'll talk to you soon. Enjoy your dinner. Boy, look at this. This right here. What a beautiful composition. It's only a portion of the frame. I'm just I think this is one of the best shots of the Casper that we've taken right now. Good music for it too. Mysterious, eerie, ominous. Donald says this is a cartoon space helmet with an antenna sticking out. Is that what you're talking about right here? That's just something. Wow. Look at the complexity of the nebula here.
Yeah.
Extremely complex. Let's see if we can, and it goes all the way down here. Let's see if we can tease out some more detail here. Let's do it this way. And maybe this way. And bring it back a bit. Now, let's see what else is there with this one. Okay, well, there's a lot more there. Look at all that, huh?
Can you zoom in on the upper bright area for a moment?
Sure. But you see all this dust here, guys, mixed with this nebula, this diffuse hydrogen emission. Amazing. Let's black this back out, back it back out. Now let's zoom in on this guy up here, as Daryl asked, because it's really cool.
Okay.
Wow.
Those two stars come out better now.
Mm-hmm.
There's actually another small area of reflection nebulosity just out of view to the top.
Out of view, yeah. It's up there. You talk about this one up here.
Showed a little better before. Yeah, that
right there.
That right there.
Yeah, all right, get back here.
There it is.
Yeah, right there. Rolls there. There we go. Yeah, that's really pretty. Wow. This is all live astronomy, guys. This is absolutely happening right before your eyes right now. No one's doing this. No one. I've looked. There's people doing streams, but no one's doing this. No one's touching this.
Oh, you're
Why
doing
is
it.
that? I'm the only one. Why? You would think that people would just jump at the opportunity.
Yeah.
This is interesting right here.
Uh-huh.
Here's some dark nebula here in front of reflection nebula, and it's blocking the reflection nebula behind, and it's the reflection nebula is coming out from behind it, and it's kind of silhouetting this nebula right here.
It's really something.
It is. If you're in a spacecraft, you might notice a subtle milky glow to space around you if you're in the heart of all this. You might. I mean, it's very, very low density. Not a lot of particles per cubic centimeter. You know, anywhere between 10 and 30,000 particles per cubic centimeter. And that's not a lot. Because in a cubic centimeter of air, we've got 2 times 10 to the 19th particles. It's just, oof. So, talk about low density, you know.
You're gonna make me yawn.
Well, look at that. And the dust, I've told you before, guys, is brown because of what it's made of. And so when we look at this dust, there's a lot of silica in here, a lot of carbon. Where did it come from? Well, the silicon was made in the hearts of big, massive stars, released in supernovae. The carbon was made in the outer atmospheres of older stars that are what we call that asymptotic giant branch. A lot of carbon, and the outer atmospheres in part would have a lot of this carbon, and thus that material is freed up when the star goes supernova. The silicon is freed up when the star goes supernova. And what's interesting is, in the lifetime of a large star, okay, let's say maybe 20 times our sun's mass, the nucleus, the core of the star, when it creates silicon, all right, it has a silicon burning shell. Do you know how long it burns? Do you know how long it fuses? When a silicon burning shell starts burning,
It's like
how long?
like a day, isn't it?
It's 1 day. It's 1 day. You know?
Before the star goes boom.
Yep. It's 1 day, then the star goes supernova as a result of that. That's not why, but you can't fuse anything past iron, and that's what comes next, iron and nickel. And it has to do with something called the binding energy, and you need so much energy to make fusion occur that at every step, when you go to hydrogen to helium, you get a lot of energy released. Helium to carbon, you get a little less energy released, but you still get energy released. Carbon to oxygen, nitrogen, etc., and oxygen, okay, less energy still, but still get some energy. By the time you get to silicon and iron, you're getting very little energy out in return when silicon burns and fuses into iron and so forth. And what happens is it goes back and forth between elements because of decay and other things that are going on. But overall, you end up with this iron core in the star's center that can't be fused anymore, because now you actually would have to put more energy in to fuse than you would actually get out. So the star doesn't do that. So that becomes an inert mass in the center of a star. So that's kind of what happens here. This is really something. We are at now 17 stacked at 45 seconds. And you'll notice... Go ahead.
If you back out to the full-size picture,
Oh, I bet you that's a good idea.
you talk about supernova remnant. I mean,
There it is.
there's a little bit of Barnard's Loop right there. If you've seen pictures of Orion, the constellation, Barnard's Loop is that great big red. It's not a complete circle, but like a big arc or a big semicircle of red hydrogen gas from a supernova going off inside the constellation Orion.
Yeah.
Orion has the Great Molecular Cloud, and it's not just a star factory; it's a supernova factory.
That's right. Boy, this is something. I don't know why I'm doing this. I'm going to do this here. I'm going to drop that down, and I am going to maximize our view here and bring this up full screen. I don't know why I was waiting for that. I don't know what I was waiting for. There it is. Wow. I honestly think this is the best one we've done.
You know,
Izabela says, wow, that was one huge supernova. Well, it really wasn't, Izabela, but the cloud just expanded outward of gas and dust. It went out into the universe over time, and it gets bigger and bigger, just like the Veil Nebula. It wasn't a big supernova, no bigger than any other, but it did have time to expand into the interstellar medium, and that's what's happened with the with Barnard's Loop here.
and I suppose the Veil is much farther away than Barnard's Loop, wouldn't it be?
Well, actually, the Veil's about 1,200 light years away, actually.
Oh, okay. Well, they're actually comparable then.
Yeah. Yeah. This is something else, though. Look at this. This almost looks like a painting, doesn't it?
Yeah.
Let's pull that up. Bring that closer.
You know, this is kind of begging the question, but you know what you need to do after this one?
Gee, no, Daryl. What?
The Boogeyman.
Yeah, right?
I mean, it's close by, isn't it?
It's nearby.
Yeah.
Yeah, and it's a good night for it.
Yeah, if you're catching this kind of detail.
Yeah. Well, we're at 21 now, so we're going to stop this, and we are going to do that Boogeyman, which is going to be very stunning. We were shooting it through light clouds the other night, and it was good then. Not the best, but really amazing. So we have Messier 78 Reflection Nebula, and we're going to now save this. We're going to pause this first. Actually, I'll let one more come in so we can get to 22. It's literally 2 seconds away. All right. There we are. So now we'll pause it, and we will save. All right, done. And save with exactly a scene. So this is now available just like this. Look at this detail, guys. Wow.
Yeah, it's really something.
It's a beautiful night, and the Boogeyman is up high too, so this is going to be really pretty. Look at the difference in the colors. It is a perfect composition, you know? All right, so let's now do this. We want to go now to a one called LDN 1622, I believe. I think that's where we're going. So long, Casper. We'll see you again. And let's bring my telescope back so we can see that. Move over, please. Hang on. Trying to get that to move over. Thank you. All right. Make up your mind. Make up your mind. All right, it'll move over. Okay, so now let's get the Boogeyman up.
What was it? LDN?
1622.
Yeah, 1622.
All right, it's literally right next to this, so it's going to show up, and you'll actually see the black central part of the nebula in the view here. There it is.
Baba Yaga.
Yeah. I think I need to move the telescope a little east. All right. I think that's going to be good. Now we got to just move it down a little.
Fantasy, when I was a little kid, the Boogeyman was a dead tree that lived on the road between our house and the grocery store we went to. There was several dead trees there, big old, real gnarly looking, dead tree branches and stuff. I got that from the trees in the movie The Wizard of Oz. I had a nightmare about them one night, and those trees in The Wizard of Oz were the trees down the road. They were
trying to wrap their arms around you.
I was in bed, and they were all standing sort of in a circle around my bed, glaring down at me. and they started bouncing the mattress, and I started popping up in the air, and then it turned into a falling dream, and I woke up.
They were aliens. You were abducted.
Could be.
See, I had nightmares with the movie or Babes in Toyland. Remember Babes in Toyland?
I'm not sure I ever saw that.
Yeah. That gave me nightmares. Okay, we're going here. And let's go into our live stack. And let's clear this beautiful picture, which will... Now let's get our LDN 1622, the Boogeyman Nebula. Has its own little reflection nebula in one corner. Just beautiful.
If this is so close to M78.
Wow. I may have to reposition.
I guess.
Let's find out.
Well, the dark structures here could actually sort of.
Oh, this is perfect.
Be related to the ones we saw in Casper.
Maybe.
You know what I mean?
I do. So the little reflection nebula I was telling you about is right here. You can see it. Look at that, huh? Wow. The majesty of the universe just unfolds before us with this. See, the second one comes in and you see how it gets darker. That's the noise going away and the data coming back out toward us. Yeah. Let's pop this over here. And let's color correct. This is going to show us the red better. Okay. Look at that. Now, the angle at which we're looking at it, it's not conducive to seeing the boogeyman, per se. We'd have to rotate this 90 degrees or so to the left.
Yeah.
So if you want to see the boogeyman, put your head on the right side and make this the top and this the bottom, and you'll see it. But honestly, what I was saying before, okay, it is this little feature which I think is just so cool. Right? That little feature right there. Right? A better way to actually show it is just do it this way. Okay. That's a little reflection nebula in here, which I think is really astonishing. It's very sharply defined on one side. Izabela says, Casper, the friendliest ghost, is on the server. Hey, Carolyn Corey, how are you? Carolyn Corey has a movie called Tear in the Sky, and Carolyn's a friend, and the movie is phenomenal. If you get a chance to see it, please do. Okay, and the person who made it is right here in our chat. I just saw you now, Carolyn. Hello, good to see you. Are you going to be? Oh, you're going to be at Alien Con as well. I'm gonna. A&E's bringing me to Alien Con to speak on a panel and maybe do some other things. And I saw you're going to be there, so it'd be nice to see you as well. I think it's Alien Con, right? You're going to be at Contact in the Desert as well? Because I'm going to be at Contact as well this year. First time. I've never been at Contact. And I'm actually going to do one of these live streams with the observatory one of the evenings as well for everybody, weather permitting. But I also have a talk to do. It's so nice to see you. Izabela saw the movie. Carolyn, see that? Okay, Boogeyman Nebula. Boogeyman Nebula is all these things right there. By the way, Carolyn, David Mason called me the other day. We had a very long talk. And we have some ideas. We have some good ideas. So we need to talk. I don't know if you've talked to him since we talked. David Mason is an inventor and electronics genius. And I count him as a friend. And we talked about inventing some technology to help find alien technology at play in our local universe. Yeah, he's working on the sequel now. Very good.
David Mason?
Yes.
It's my twin brother's name.
Wow. That's because you're Daryl Mason, of course. I don't think you're any relation to David. Well, thank you, Izabela, for putting up that information for her movie. That was very kind of you. See that, Carolyn? We have people out here that work on your behalf and you don't even know it, right? I'm looking forward to talking to you about the sequel. I'd be very, very excited to work with you on that. Oh. Look how beautiful this is coming out. Holy cow.
William Shatner's in it.
I know William Shatner. I don't know William Shatner. I worked on The Unexplained for one episode, and that was it. Okay. I look forward to hearing from you, Carolyn. I'm going to remove this name because we know what it is, so come here, you. And I'm going to maximize this one as well. So let's drop this down. And my hand is not being listened to. Drop it down. It'll be up. It'll work. Just a minute. And we'll maximize this. Oh, I know why. Okay. Okay. Now I can drop this down. Okay. And now we can maximize and get rid of that. And look at that. Holy cow. Carolyn, this is just that's pretty, isn't it? That's as good as we've seen it ever. Don't you think?
Oh yeah. Louise Donald-Cumder, it's too early to catch the comet in the telescope.
Yeah, thank you. Good to see you, Luis Rodriguez. It's nice to see you. And we will be viewing the comet in the telescope by the 30th of January in earnest, because it'll be high enough where we can see it right away. Carolyn says, this looks amazing. This is amazing, Carolyn. We talk about looking for extraterrestrial life. Well, you know what? This right here, this is where it will occur. In these dark, icy, cold patches of the universe. The stuff in here is is composed of the fundamental foundational elements that create life. It has dust, it has all the residue and debris from previous supernova explosions that have coalesced and come here, and all throughout the galaxy and the universe. And it's in here that this dark dust is, and it's in here where hydrogen gas, which you see some hydrogen throughout here, that is going to form stars and planets inside here at some point someday, if it's not happening already. And one of those things, like right there, that little tiny black dot, we look at those black areas in the universe and say, hey, that's a self-condensing globule of something. Something is causing that to condense, most likely gravity. And when it's condensing like that, it's going to form potentially a star and possibly a star system with planets. And so we literally are looking at the very strong possibilities that life is forming and that planets are forming right there in front of us. And we're seeing it right here. And so that's the kind of thing that keeps me up at night doing this. You know, it's 1 o'clock in the morning for me, but I don't care. I'm fine. This is just a wonderful view. You know. So let's, for instance, let's go back here. I want to show you this, guys. This region right here is the reflection nebula I was telling you about. Look at the detail in here, and this is the Boogeyman. This scary dude here, you know. Really something, and he's a long, drawn-out, frightening dude, and he has some amazing detail at the end here. And here's that dark, what looks like a condensing globule, gravitationally condensing globule. That could be making multiple stars and planets all in one spot. Carolyn asked, can we see the event horizon with this telescope? No, event horizons are not visible at all with a conventional telescope like this. And you don't see an event horizon really at all with a telescope. You see what the event horizon does to the surrounding area of a black hole, because that's where you would see it, right, is a black hole. And the event horizon itself is a place of turbulence. It's a place where there's a lot of energy, a lot of high magnetic fields, and this stuff will actually cause radiation, X-rays and so forth, to be radiated away from the black hole at that interface. And you'd see that, but not with a conventional telescope like ours. You'd see that with a radio telescope. You'd see that with an X-ray telescope. You know, seeing things that we can't see with our eyes. It's not a visible light. This is a visible light telescope. So that's something we can't see with visible light. We can with X-ray, and we can with radio. We can with, to some extent, infrared as well. We can see the heat generated by some of these interactions. Judy M is leaving us. Good night, Judy. Hope you have a good evening. Thank you for stopping by. You've been here for quite a while. Okay, we've stacked 16 of these. We're going to go more because whenever you have a dark nebula, you want to stack as many as you can to help get the data of that dark nebula to come to the top of your stack and really be impressive. Yeah, there's an Event Horizon telescope. Yeah, I wasn't sure if that's what you're asking. The Event Horizon telescope is actually a series of like 8 different telescopes, but they're all radio telescopes, and they are actually, it's interesting how they're laid out. They're laid out on the whole planet, and what happens is, if I come back, I'm coming back from the ether here. As the Earth rotates, the telescopes are in different spots on the Earth, and the Earth is 8,000 miles in diameter. So as the Earth rotates, each of those telescopes sees the object, and as the Earth rotates, it makes an arc across the Earth as it rotates of data. And it catches data. For this arc belongs to, say, the telescope out in Hawaii. All right. Another one is a telescope overseas, and that arc, those arcs continue, and they add up to a logical set of data that could approximate, in a crude manner, the diameter of the Earth as a telescope. So basically, they have an 8,000 mile diameter telescope, and all of them together add their light together and allow us to see something incredible, and that is the black hole's event horizon shadow in a distant galaxy like Messier 87. I mean, that galaxy is, what, 44 million light years away, I think, and we're seeing the black hole in the center of that galaxy. However, that black hole is massive. It's several times the size of our entire solar system. That's how big this black hole is. So black holes can be big. And the one at the center of our galaxy is also the stars and the stuff going around that black hole are moving so fast that by the time the Event Horizon Telescope actually captures images of it, it's blurred. Because it just takes like an hour or a few minutes to an hour for this material to circulate and circle around the black hole. So the energy is all stretched out, streaked, and blurry. Same thing with Messier 87, even though it's farther away. We're seeing again a rough approximation of it, but it's actually the best image we've taken in human history, and the first time ever of a black hole.
Excuse me a moment.
All right. Luis Rodriguez says, from all the fake unidentified flying object videos out there, is there anyone that actually makes you think it could possibly something? Okay, I'm sure you missed a word. What's the most interesting video? Okay, all right. I saw one video. It's footage from a man that was using a 16 millimeter camera, I believe, at a sports park where he was capturing imagery. Okay, and it was like 1951 or 52, and his name was Nick. I can't remember his last name. I bet you Carolyn knows it because she's probably heard of the case. And he captured two objects going through the field, and it's a 3-second video, but it's the best video of objects that may not belong here that I've ever seen. And they're just bright dots moving through the sky. If they were meteors, they'd leave smoke trail, because if they're that low to be seen, that bright, it means they're burning. These didn't leave any smoke whatsoever, and the camera certainly would have shown it. Okay, and then if they were anything else, we would know about it. If it was a man-made, human-made aircraft, we would know. And there were aircraft in the air, of course, because there's always aircraft in the air. But this wasn't it. So the Nick Mariano footage, okay, is by far, to me, one of the best cases that there was possibly something that happened. Now, another possibility is when I have a business where I do work for the Navy at times, and one time I did some work and they said, hey, you want to go on a submarine? So I went on a nuclear submarine. Best time I had being seasick. And because on the surface it rolls like a sewer pipe with end caps on it, but once you're underwater, it feels like you all feel now. Very, very calm. You can't tell you're moving. You feel vibrations as we go through different temperatures of water. But to overcome my seasickness, I was sitting in the sonar shack, a little area off the main control room. And as I did, I was waiting for my stomach to calm down. And the kid running the sonar had something race through the sonar at very high speed. And he called con sonar, fast mover, fast mover. And the executive officer, known as the XO, comes around and says, what do you got? And he saw the kid responded to him. He gave him a bearing and a range. He couldn't hear that. But he said, when asked how fast it was going, and I heard this loud and clear because the kid didn't know what to do with it. He had his hands out like this. And he goes, several hundred knots, sir. And he had like this, like, what do I do with this? It was unlike anything the kid ever saw. And the XO, he just said, okay, log it and dog it. And the kid said, sir, yes, sir. Turned back to work. And I was like, haha, no. And I got up. Remember, I'm a big shot now. I was invited to go on the sub. And I said to the XO, XO, I'm familiar with these fast movers, as they called them on the ship, in the boat. I said, is there anything I can help you with? He looked at me and he goes, Dantonio, right? I go, yes, sir. He says, you having a good trip? Yes, sir, I am. He goes, let's keep it that way. And he turns and walks away. Okay. So Mr. Big Shot here was taken down a few notches, and I learned the lesson the hard way. And some years later, I ended up doing a job for the Joint Chiefs, okay? And I went down and I talked to the Joint Chiefs, and I asked one of the chiefs who was in the know, I said, what can you tell me about the Fast Mover program? I mean, anything? And the chief didn't have to say anything. He didn't have to say, he could have said, what's that? He didn't. We had a working relationship. He looked at me and he says, oh, I'm sorry. I can't talk about that program, Mark. And I went, okay. In other words, he admitted it was real. I was like, wow. Outstanding. So I drove home from Washington all the way back to Connecticut. I was like, Oh my gosh, it's real. It's real. It's real. And I was just blown away. Just blown away. Wow. So anyway, as far as there being evidence of actual unidentified flying objects, there's all kinds of evidence. My experience was evidence. The experience of the Nimitz, incident, folks, was evidence. The videos that have yet to be released, I think, are evidence, and that's something that's very important to release. And I'm just waiting for that to happen. Just waiting for that to happen. And there's people that say, well, how do you know? How do we know you're telling us the truth? You don't. You don't, right? But I told this story decades ago because it happened decades ago. Decades, okay? Several decades, plural. And then the Nimitz incident came out a few years ago. I was telling the story long before the Nimitz incident. So it's interesting how the Nimitz incident story perfectly parallels what happened with me. Because I told this story a long time ago. And then you hear Dave Fravor talk about an object coming up from underwater to meet something on the surface, what they were calling a tic-tac at the time. And he said it was making this frothing and bubbling at the surface, then it went back down and this thing took off. Well, maybe that thing under the water, if that was really there, was one of these unknown submerged objects like they saw on that submarine. I just know that if they're here, they're going to be where we are not. And where we are not is in the deep ocean. That's the best way to observe us, to be honest. All right, there you go. Enough of story time.
Supercavitating torpedo.
Those are very loud, and this was almost silent.
Mm.
The supercavitating torpedo you're talking about is, I think, the Skval torpedo. And the Skval is a Russian invention, and it creates a laminar layer around the outside of the torpedo made of steam. And so, effectively, this torpedo can race through a steam cloud of its own design.
Yeah.
Kind of like the train that lays down its own tracks to keep going forward. But that works too. If you had a train that could just keep putting that circular track down and roll on it, well, it can keep going. It could work. So the Skval works the same way. Look at this! Wow, this is gonna be the best one we've ever seen.
Well, it's really something.
Best Boogeyman. Okay, the Boogeyman is also known as LDN 1622. That's Lynn's Dark Nebula. Okay, but I'm gonna call it the Boogeyman Nebula, and it's a DN RN. Dark Nebula, Reflection Nebula. This stuff here is actually dark nebula. It's not emission nebula. The color is actually not as red. It should be more brown. All right, so we'll get to that. Okay, let's do this. And let's actually maximize just to see what's there. Okay.
Well, that could be
So now
diffused hydrogen, couldn't it?
I mean, it could, but I think that in this case, I think this is not diffuse hydrogen, but I think some of it. You know what though? I think some of it is diffuse hydrogen actually, because I'm now correcting myself because I actually when I processed this, I found that there was a very red component to a lot of this stuff that's in here, and I figured that's got to be diffuse hydrogen emission as well. So it's possible, yes. So never mind the last 45 seconds. All right. Okay, so
What are you thinking of next?
I'm thinking of bedtime.
Yeah, I hear the pumpkin coming. The pumpkin coach
Except, we've done 32 of these, and I like the fact that we're doing 32 45-second shots. The guiding is absolutely perfect. Okay, we've nailed down the system so we can actually do the auto-guiding system perfectly. This is very well placed. This is going to be one of the nicest shots of the Boogeyman we've ever made. Let's zoom in. There's that reflection nebula at the head. And now, one of the things you can see is the different densities of this dust. This is denser than this stuff. And you can see how this stuff is a lighter brown than this stuff, which is darker. Okay, very interesting. And it trails off back here. Wow. Look at the fine filaments in this, too.
Yeah, I was just going to say that right there.
Looks like hair. It's a very, very fine filaments. So, we're capturing some very fine detail. All right, so we're going to call it. Go ahead.
The one dark area that has the very fine filament coming out, I think we said before, it looks like a hummingbird.
Oh, I mean this one?
Yeah, and the filament's like his beak.
Like this right here.
Yeah.
Yeah. And there's the wings.
I think we remarked on that before.
Yep. Very nice. And this needs a lot of those stacked images because we're trying to get as much data in the darkness here as possible. So when we actually process it and remove the noise, we're going to substitute the noise with other pixels like it around it. And that's going to actually make it very smooth, and just you zoom it tremendously. It'll be beautiful. And see, subtlety is the name of the game as well. If you look over here, you'll see that there's actually a border of material here. What looks like a reflection nebula behind it, and maybe some more subtle emission here. But you can see this is an open cavity here, leading to some more dust behind it. That's really, really pretty. Wow. Oh, yeah.
So is the big bright star on the right what's lighting it up, or just a line of sight thing?
I don't know. I mean, what's interesting is that, and Daryl, you know this, most of the time people might think, oh, the big bright stars are what are doing it. But in fact, it could be like this star right here.
Yeah.
And it could be that star over there. It depends on what star is actually doing the lighting. It depends on which star has the most energy and where it is. This star may be close to us. It may be much further than any of this.
I dare say the one down at the bottom right, the reflection nebula, that appears to be a star inside it. That must be actually there.
I believe that the star that's in there is what's actually lighting up this part of the nebula. When we've got nebula around the star like that, it's a pretty sure bet. But notice this edge. Look at this right here. Look at that edge of nebula that's doing both. Looks like emission and reflection. It's doing the scattering thing as well. Wow. Yeah, this is really nice.
Yeah.
Yeah. So again, this is the guy.
Maybe I can find out real quick.
Yeah. Donald Kunzer says he's seen the same shape in the Mandelbrot fractal set. Yeah, maybe so, actually. I can see that. Outstanding. What a good night. See, on nights like this, I don't want to close down, but I know I have to. Fantasy, man, thank you for coming. It's good to see you. Thank you, Vera. You're awesome for coming, and thank you very much for the donation. Good night, Bonnie. Thank you for coming. Good to see you. We're going to end at the 40th exposure of this. Cosmic Ray says, so let's process this into a painting instead of a one of those what do you say, science images? Good science image. Well, if you process it right, it's going to look like a beautiful science image, you know, as well as a painting. We'll do that. All right. Well, there we go. And we shall now save it under its name. And then save exactly as seen. Whew, there we are. What a beautiful, beautiful photo this turned out to be. Hello, D. Smith. Good to see you.
Good night, everybody.
You're welcome. Yeah. So we're going to head out of here now. I want to thank you guys for coming. And just remember that we love seeing you. We love hanging out with you. And we know that you guys are the best. All right. And once again, that music means it. All right. That is the end of the stream. This is the Boogeyman Nebula. You'll see it up there on the server in just a few minutes. And unknown and unlike what Ray says, make sure you keep looking up, all right? Except while you're driving, all right? Have a good night, everybody, and we will talk to you the next time. See you later.
Good night, everybody.